Hello students, welcome to the class. So we will today do with the rest of the part of this chemical bonding and molecular structure part. Okay, so today will be day 6 of this 40 days crash course. So please join the class. We will begin this class at 4:04. Today will be a very important part of this lecture as we will be covering your MOT, the valence bond theory, the whisper theory. Okay, so just quickly join the class. So in the previous class, we talked about the Lewis structure, right? And then we talked about part of this hybridization. We will continue with that part today. So please join the class. Just comment it down if you are ready to go with the class. Hello, hello Advatam. So I am seeing very less participants. Today we will cover the most important part of molecular orbital theory, valence bond theory, and our hybridization as well as the whisper part. So this will be an important class for the chapter chemical bonding and molecular structure. Now let us move on to the lecture. So this is our disclaimer. If I talk about the names of the specific topics that we will cover today, then those are the valence bond theory. Then after we will see the concept of hybridization involving sp and d orbital. Then our whisper theory, molecular orbital theory, and the part which is given after this molecular orbital theory is the hydrogen bonding and the effect of hydrogen bonding, and lastly the metallic bonding. So this will be an important class for those who are looking for the chapter chemical bonding and molecular structure. So those who all are facing difficulty in predicting the geometry or predicting the shape, today you will get a clear idea about how about you predict the geometry or how you predict the shape of a given molecule. Okay, so let us begin with the first thing, which is valence bond theory. So to understand this valence bond theory, you must first know what is orbital overlap and bond formation. So this was given by Pauling and Mulliken. So this orbital overlap concept was given by Pauling and Mulliken, and it explains the bond formation in the terms of overlapping of orbitals. Example, suppose we are taking a hydrogen molecule. In a hydrogen molecule, there are two hydrogen atoms and each of them will have 1s orbital. So the two 1s orbital of the two hydrogen atom will be singly occupied and they can overlap with each other to form a bond. Now because of this overlap, orbital overlap, what will happen? The electron density between the nuclei increases, and as the electron density increases, the positive charges are attracted towards each other and this creates a bond. So you can think it of a way to arrange the charges. Suppose we have two atoms of hydrogen, both of them have electrons around them. When these two atoms have overlap of their 1s orbital, then between the two nuclei you will see that there is a accumulation of electrons, and that results in the formation of bond. Now how many types of bonds are possible on the basis of overlapping of orbital? So there are mainly two types of bond. which we will cover in this class. We have a third type of bond also, you know about this. We have sigma and pi, then we have delta bond. So we will not talk about delta bond in this class. Now starting with the first, which is sigma bond. How it is formed? It is formed by the end to end overlap, or we can also name it as axial overlap between three possible combinations. So your sigma bond is only formed if there is an overlap of SS or PP or SP. So these are the three combinations that are possible for the formation of your sigma bond. Remember, every single bond that you see, so suppose two atoms are joined together by a single bond, then that single bond will be always formed as a result of head on head overlap, and hence it will be a sigma bond. As I said before, whenever there is a bond formation, the electron density is accumulated between the center of the two atoms or between the two nuclei of the two atoms. Now we can take examples of sigma bond formation. So in the first case, your s orbital is combining with another s orbital, and hence it is forming a sigma bond. Now your s orbital is symmetric in nature. No matter in which direction your s orbital is oriented, it will always result in a sigma bond formation due to the axial overlap of the SS, right? But when you are taking a p orbital and a s orbital, then you have to be particular about it. Now what is the meaning of particular about it? To understand this thing in a way, you know that your sigma bond, okay, is formed by the head on head overlap. To do this, your p orbital must be aligned in the z direction. So basically, whenever in normal terms, in conventional terms, we always take the z direction, and hence the pz orbital is taken for the formation of sigma bond with the s orbital. Now this may change in the question. Suppose your question says that the or the orbitals are approaching each other through the x direction rather than the z direction. Then in that case, you will take one s orbital and one px orbital. Again, I am repeating this. This is very, very important to remember. Suppose your overlapping is occurring along the x axis. Then in that case, you take the px and the s orbital. Suppose your overlapping is taking across y axis, then you will take s orbital and py orbital. If it is not mentioned, if it is not given in the question along which axis you have to take, then generally we see that sigma bond is formed along the z axis. So we take the pz orbital normally. So what you will remember, that the formation of sigma bond can only be possible if your p orbital is oriented along the axis where your orbitals are approaching to each other. So you can clearly see these two orbitals that are aligned along the same axis, and it results in the head on head overlap. Got it? Now suppose in place of this p orbital, you take a perpendicular p orbital like this, okay? Then what will happen? It will result in zero overlap, okay? So always there should be an head on head overlap between s and p orbital. Now moving on to the next type, which is pi bond. Now how is the pi bond formed? So basically in the pi bond formation, there is a incomplete overlap of orbital, or you can also say it as sidewise overlap of the p orbitals, and this thing results in the formation of pi bond. You can see here an image of two p orbitals combining with each other, and they are overlapping sidewise. So let me explain the previous concept with the help of this also. Suppose rather than taking two p orbitals which are parallel to each other, you take two p orbitals which are perpendicular to each other. So can you think of two p orbitals which are perpendicular to each other? Suppose I am taking one px and one spy. They are perpendicular to each other or they are parallel to each other. What will be the case there? Again, I am repeating my question. You are taking two p orbitals, and one of the p orbital is px and the other one is py. So in that case, are they perpendicular to each other or are they parallel to each other? And in which of the case it will be forming a sidewise or doing a sidewise overlap? Which is the best configuration for doing a sidewise overlap? Is it parallel or is it perpendicular? Anyone who is willing to give the answer? Again, I am repeating my question. If I am taking two orbitals of two different atoms, one is px and the other one is py, are they perpendicular to each other or are they parallel to each other? Okay, so they will be perpendicular to each other. Now suppose here the example that I have taken, there are two p orbitals that are doing a sidewise overlap. Okay, now they must be parallel to each other, and that is only possible if we take those orbitals only that are oriented in the same direction. So if I am taking one as px, the other should be also px. Yes, it is important for two p orbitals to be parallel to each other to do a sidewise overlap. Okay, got it? Now in case of perpendicular, again you will get a zero overlap. Now I am going back to this s and p case. If you take a p orbital along the x axis, means the px, I am taking the px, and your overlap is occurring along the z axis. Just try to analyze this situation. The first thing I am saying that you are taking a p orbital which is oriented along x direction, or simply you are taking a px, and your overlap is occurring along the z direction, and that with a s orbital. Now will it be a good situation to do a head on head overlap? If it is not a good situation, suppose that if it is not a good situation, what will it result in? Will it result in a zero overlap, or will it result in a good overlap? So what can be your answer? So what I am taking here is a p orbital oriented along x direction. Your overlapping is occurring around the z axis, and that with a s orbital. Now what will be the result? Whether it be a positive overlap or a zero overlap? Anyone who is willing to answer this? So I am fixing the approach of these two orbitals along the z axis, and I am taking a px orbital. So whether it will be a head on head overlap or it will be a zero overlap, what kind of bond will be formed? If no bond will be formed, what is the reason behind it? I am giving you 10 seconds to think over it and give the reply. I am saying that we are taking two orbitals. One is s orbital, the other one is px orbital, and your atoms are approaching, or your orbitals are approaching along the z axis. So this is my question. Now I am asking you that whether it will result in a positive overlap or it will result in a zero overlap. What will be the outcome of this? So this kind of conceptual questions may be asked in your exams. So basically here what will happen, due to a harsh situation of two orbitals, they out of phase with each other. So if you consider a p orbital, it will have a positive part or a positive phase and a negative phase, whereas your s orbital, if I take it as a single phase, it will be a positive phase. Now in case your px orbital is there and your approach is along the z axis, then it will result in a zero overlap. Okay, you can just try to draw a diagram with the same information that I have given, and you will see that there will be a zero overlap. Now If I am considering a double bond, it will always contain one sigma bond and one pi bond. So that is for sure. And for a triple bond, there will be two pi bond and one sigma bond. Now there can be anomaly in this, like in case of carbon you will see an anomaly. We will talk about that in the upcoming slides. Now moving on further, we will now see the concept of hybridization. We have just witnessed what is the way of overlap, how two orbitals can do a overlap. Before the overlap, there is a thing which happens in your within the central atom, and that is known as hybridization. Now, what is hybridization? It is the intermixing of the atomic orbital of nearly the same energy, and as a result of this intermixing, you will get new atomic orbital, new kind of orbital known as hybrid orbitals. Got my point? What I am saying? So, what happens? Two or more than two atomic orbitals combine with each other or intermix with each other, and they should be of nearly the same energy, and after mixing they form a set of hybrid orbitals. Now what are hybrid orbitals? Those orbitals which have the same energy, same shape and same size, and they are identical, means they are identical in all aspects. For example, if you take the case of beryllium, then beryllium, if you remember, then it can be it can have a maximum coordination to or maximum linkage to two surrounding atoms. For example, if you take the case of BeCl2, okay, so BeCl2 has a structure, a linear structure, where beryllium is present in the center and two chlorine atoms are attached to it. Now, how does this happen? So basically, your beryllium atom first undergoes sp mixing. Okay, there is an intermixing of atomic orbitals. Your s orbital of beryllium mixes with the p orbital of beryllium to form the sp hybridized orbitals. Got it? Now next what will happen? The two chlorine atoms, okay, the two chlorine atoms will do an overlap with the two hybridized orbital of beryllium with their p orbital to form the BeCl2. Okay, so this is the way your molecule is formed. So in a way, I'm combining two concepts here. What are those concepts? First, we talked about this overlap, right? And second, we talked about hybridization. Now, these two concepts are mixed together to explain your bonding. Suppose if you take the case of beryllium chloride, there is first the concept of hybridization, which plays the role by mixing the s orbital and p atomic orbital of the same beryllium atom to form the sp hybridized orbital. Now next what will happen? Next comes your role for the overlap. How? So basically the sp hybridized orbital overlaps with the two p orbitals of the chlorine to form the complete beryllium chloride molecule. Okay. Similarly, if I take the case of methane, suppose if I take the case of methane, first what will happen? The carbon which is present there, that will do a hybridization within itself to create a sp3 hybridized orbital. Now a sp3 hybridized orbital has 4 orbitals in total, 3 of p and 1 of s. Okay. As a result of this intermixing, we will get a sp3 hybridized orbital where 3 hybrid orbitals are there. Now, 4 hybrid orbitals are there. Now, each hydrogen atom that is surrounding your carbon will do a overlap with this hybrid orbital to form the CH4. So, one s orbital of every hydrogen atom will do an overlap with the 4 hybrid orbital of the carbon to form the CH4 molecule. Now, the d orbital is something which is very interesting. So, there is something known as dsp2 hybridization, We'll talk about this DSP2 hybridization in the upcoming slides. So what is important here to notice that in the case of DSP2 hybridization, there are multiple options available for the case of d orbital. So there are dxy, dxz, dyz, dx square minus y square and dz square. Now, depending upon the d orbital you are taking, the corresponding things will be formed. Like in the case of dsp2, the d orbital which is involved is your dx square minus y square. But if you are taking the sp3d, the d orbital which is involved is your dz square. Similarly, in the case of sp3d2, the d orbitals are dz square and dx square minus y square. So this is very important to think about. Okay, what I am saying, that in the case of dsp2 hybridization, the d orbital which is involved particularly is dx square minus y square, whereas in the case of sp3d, the d orbital is dz square, and in the case of sp3d2, the two d orbitals are dz square and dx square minus y square. Now you can see a very important significance here. We are taking two similar kind of hybridization. Got it? But by changing the d orbital, we are getting two different shapes. For example, if we take dz square, we will see a triangular bipyramidal shape. But if we take a dx square minus y square, in the dsp3 we will get a square pyramidal shape. Is it clear to all of you? Any doubt in this? So this is something which is not that much important for you, these 3 points, these 2 points, but the above points are very important and you should know how a molecule formation is taking place. So there are two steps basically. First is the formation of hybrid orbital and second is the overlap. We can take more examples. Suppose I am taking the case of ammonia. Got it? So the in ammonia what will happen? First there will be a intermixing of atomic orbital and that will result in sp3 hybridized orbital, means 3p and 1s orbital will combine to form 4 hybridized orbital. Now this 4 hybridized orbital will do a overlap with the 3 hydrogen atom. Got it? And one will be remaining as your lone pair, and that will result in the ammonia molecule. Is it clear to you? Any doubt till this? So you can just leave these 2 points. So these are something which is not that much important, but you must understand the way your molecule is formed. Okay, got it? Any doubt till this point? So if you have a doubt, you can just give it here. So can we move forward? You got the idea of how the molecule is formed. Now we will move on to how we can know the hybridization without uh, doing any perceptions, right? So we will see a direct formula to calculate that same. Now that is accurate to a very large extent, of course. So if you have a doubt, you can just post it here. What is the difference? Okay, so what are you asking about? Which difference we are talking about? Between the dsp3 and the sp3d. Okay, so basically, suppose we are taking a dsp3 hybridization, then what is the probable case? What is the principal quantum number you must be taking? That is the difference. Okay, so suppose I am taking a sp3d, it means your d orbital is present on the outside, means it is having a higher principal quantum number. Okay, so it is possible that I am taking a 3s and a 3p and a 4d. So in that case, your 4d is present outside. But rather than that, if I take a 3d, a 4s and a 4p, so it will be named as dsp3. So it is depending upon which d orbital you are taking. Whether you are taking a d orbital which has a lower energy than the sp, then in that case you will call it as dsp3. If you are taking a d orbital which is having a higher energy than your s and p, then we will name it as sp3d. Got it? Now we will move on to a very important point of the JEE Mains. Basically, if you see, questions are mostly asked from the hybridization related to, first of all, the first and second period, and most specific the third period. In the case of third period elements, the energy of the 3d orbital, see that it is the same case I was talking about. The energy of the 3d orbital are compared to that of 3s and 3p, as well as to the energy of 4s and 4p. So there are two cases possible. Okay, so there can be a hybridization between the 3d, 3s and 3p, or there can be a hybridization between the 3d, 4s and 4p. Got it? If your 3d and 3s and 3p are overlapping, then that will result in a sp3 dehybridization. In place of that, if there is an overlap between the 3d, then 4s and 4p, then that would result in a dsp3 hybridization. So this is the difference. Okay, so it is basically the place where it is present. Since your 3d orbital has a higher energy than 3s and 3p, then the overlap, the intermixing would result in a sp3d. Whereas in the case of 3d, 4s and 4p, your 3d has a lower energy, so that would result in a dsp3. Is it clear to you? So as a result of this, hybridization of either 3s, 3p and 3d are possible, or 3d, 4s and 4p are possible. The first set, means this one, would result in sp3d, and in this case it will result in a dsp3. Is it clear to you? The difference between the dsp3 and the sp3d? Now we will see the different kinds of hybridization and the shape related to it. So I put upon mainly about this d orbital, because this is something which is difficult for you. The first is dsp2. Now dsp2 results in a square planar shape, whereas the sp3d results in a trigonal bipyramidal. Next, if we have a sp3d2 with one lone pair, got it, then it will result in square pyramidal shape. So the shape will be square pyramidal, whereas the geometry will be again the octahedral. Got it? In case if it is having no lone pair, then the shape and the geometry will be same, whether you are taking sp3d2 or you are taking d2sp3. What did I say? I said that if you have a sp3d2 hybridization and you have a lone pair in that, then the shape will be square pyramidal, but the geometry will be octahedral. Okay, but if you have a no lone pair, if you have no lone pair in the sp3d2, then shape and geometry both will be same. Now here we have examples. So first of all, you can look upon NiCN whole 4 2 minus and PTCl4 whole 2 minus. Both of them have square planar shape, whereas your PF5 and PCl5 have trigonal bipyramidal shape. So we'll talk about how to calculate this hybridization and all. Then we have this BRF5 and IF5, which has one lone pair and a sp3d2 hybridization, and it forms square pyramidal. Now moving on to some examples of hybridization. First, we will talk about the sp3d hybridization. Why it is important? So, importance lies in the example of your PCl5. In the case of PCl5, two sets of bonds are possible. Means there are 5 PCl bonds. So, 3 PCl bonds are of different type and 2 PCl bonds are of different type. And it is seen that that's two sets of PCl bonds, which are your axial bonds, that are elongated due to more repulsion. So, you can see it here. So, this is your axial one, right? And this, which is present on the plane of on the vertices of a triangle, these three chlorines are equatorial one. It is seen that the bond length means the axial bond length of PCl is greater than the equatorial bond length of PCl. Why is it so? It is due to the repulsion. So basically, this three bond pair which are present on the triangle shape, they repel this chlorine molecule. To reduce the repulsion, this chlorine molecule moves away from the phosphorus to reduce the repulsion, and as a result of that, we get a longer axial bond as compared to your equatorial bonds. So, as a result of this larger bond, we will see that your axial bonds are weaker and they are reactive as well. So, this makes your PCl5 overall very reactive because of this weakening of the axial PCl bonds as compared to the equatorial bond. Any doubt in this part? Why the axial bonds are longer? So, this is due to the repulsion. The repulsion between the equatorial and axial bonds means the electron density of the equatorial and axial bond. We see a elongation of the axial bonds. So, if you have a doubt, you can just comment it here. Okay, now we shall move forward. So, is it clear to all of you? So, this is a very important example from your exam point of view. This PCl5 diagram. Okay, now we shall move forward. Next is sp3d2 hybridization. Now, in your SF6, there are 4 SF bonds which are in the same plane at right angles to one another, and they are directed along the vertices or corners of a square. Whereas the two hydrogen atom, now they are at a right angle above and below the plane of your square. You can imagine it here. You can see that there is a square formed by the 4 fluorines with sulfur on the center. Apart from this, we have a fluorine atom which is lying above this plane of square and a fluorine atom lying below this plane of square. So, this is your overall view of your SF6 molecule which is having a sp3d2 hybridization. Now, students, focus here. Why we are calling it sp3d2? Just count the number of atomic orbitals which must have combined to form this sp3d2 hybridization. Of course, there is one s present here. Then we have the combination of 3p and we have the combination of 2d. If you count them total, then 3 plus 2 plus 1, 6. So 6 atomic orbitals are combining together. As a result of that, we are getting 6 hybridized orbital. Okay, and those 6 hybridized orbital are overlapping with this 6 fluorine atoms. And if I tell it specifically, it is overlapping with the p orbital of the fluorine atoms to form this complete SF6 molecule. Is it clear to you? Now, how do we predict the hybridization from valence electron and attached atom? Now we will see a simple formula. Suppose you have to predict the hybridization of the central atom. So it is always predicted for the central atom. And how do you do it? So there is a way to calculate the x, which is also known as steric number or the number of hybrid orbitals. You have seen just now in the case of your SF6, the number of hybrid orbital were 6, 4 with the squares of the fluorine and 2 which are present above and below that square. Got it? Now how do we know that? That there will be 6 or 7. So this is the formula to calculate that steric number, which is x is equals to half v plus m plus a minus c. No, it is not possible to have S2P4D3. The kind of hybridization that you know or which is given in the book, that will be only asked in your JEE exams, and I am telling it for the NCRT. The kind of hybridization which is given in your NCRT book, only those kind of hybridization will be asked in your exam and not out of that point. Okay, so don't worry about it, that you will get a random situation. Now in this, what is the significance of each and every symbol? So V is the number of valence electron of central atom. Suppose I am calculating it for SF6. The sulfur belongs to the chalcogen family, so the steric number will be 6 for the sulfur. Sorry, the valence electron will be 6 for the sulfur. Very easy to predict. Then what is the number of monovalent atom? Monovalent means, so M is representing here the number of monovalent atoms. So in the case of SF6, there are 6 fluorine atoms, and you know the fluorine atoms are monovalent, isn't it? Because they form only one bond, so therefore they are monovalent in nature. So for SF6, the number of valence electron is 6, the number of monovalent atom is also 6. Then we have A. A is the charge due to anion and C is the charge due to cation. Now in the case of SF6, is it containing any charge? No, of course not. So therefore 0 will be put for A and C both. Now the total formula, if you calculate your x, so x will be equals to half number of valence electrons, 6 for sulfur, plus number of monovalent atom is 6, as there are 6 fluorines. So x is equals to half 6 plus 6, which will be equals to again 6. Therefore you can easily know the x from that formula that is given here. Now once you know the x, you can easily predict the hybridization of simple molecule. Is it easy for you? Did you get my point? How are we calculating the SF6? How are we calculating x for the SF6? Can you calculate the same value for the PF5 molecule? So what will be the value of x for your PF5? Can you calculate and tell me in the comment section? Again I am repeating my question. Can you calculate the value of x for the PCl5? Simply just count the number of the valence electron, the monovalent atom, the charge due to cation and anion, and from there you can easily calculate the value of x. Anyone who is getting the value of x for PCl5? Yes, I know the hybridization, but what will be the value of x here? If you calculate it for PCl5, yes, it will be 5. Then for the x is equals to 5, the hybridization corresponding to that will be sp3d. Okay, so in this way you can know the hybridization from the value of x. Now we talked about the Vesper theory. We will talk about the Vesper theory now. So this, why is this Vesper theory important? Why did it came into light? Now we know that for sure. We can easily know the shape of the molecule from the hybridization. If you calculate the x from there, and then you see the corresponding shape to that x value, you can easily know the shape of that molecule. But why did Vesper came into the picture? So this Vesper was taken into the picture due to the irresemblance of your lone pairs. So if you see the previous cases, you will not see the role of lone pair anywhere in your whole discussion, right? Now this Vesper alone stands for the valence shell electron pair repulsion. So someone is asking, yes, don't worry, if you are doing all the DPPs, if you are attending the lecture, and if you are able to solve the DPP within the time limit, you will surely secure marks in the exam. Okay, so don't worry, JEE is not that much difficult to qualify. Now, what is the theory? What can we say according to this theory? According to this theory, all valence shell electron pairs surrounding the central atom arrange themselves in such a manner so that they are as far away from each other as possible. Now, what is the meaning of this? So, basically, whenever you see a molecule shape, it is never perfect in shape there. There will be always a variation of the bond angle, and that variation of bond angle or that deviation from this ideal angle is due to the repulsion factor, right? So it is seen that the repulsion between the bond pair and the lone pair and your bond pair and the bond pair is different. There is a very famous sequence for it. So the repulsion between the lone pair and lone pair is highest. Then comes your lone pair bond pair repulsion, and lastly your bond pair repulsion. So again, I am just moving throughout the series that we have talked about. We first started with the concept of overlapping. So you have seen there are two kinds of overlap possible, sigma and pi. Sigma is formed by the head on head overlap, and there are three possibilities to form the sigma bond. There can be overlap between S and S, S and P and P, and they must be head on head to give a sigma bond formation. Then in the case of sidewise overlap, we saw the formation of pi bond. Remember, pi bonds are weaker than the sigma always. Got it? Now, due to the overlap, the electron density increases between the two nuclei, and that results in the bond formation. But before the overlap, any molecule that you see first undergoes hybridization of the central atom. Now there are some molecules which do not go hybridization. Those are called Dragos molecule, like pH3 we have. pH3 In pH3 there is no internal intermixing of the hybrid orbital of the atomic orbital of phosphorus before the formation of bond. But in most of the cases you will see that there is a hybridization first, and then there is a overlap with the surrounding atomic orbitals of the surrounding atoms. Okay, so we talked about the second thing, which is hybridization. Now there are multiple hybridization possible. How we can know the hybridization of the central atom? So we have just seen the formula, x is equals to half v plus m, okay, for the neutral molecule, where x is a number known as steric number, half, then v is the number of valence electron, m is the number of monovalent atom. Got it? If you put all the values, you will get a specific steric number. Suppose you got steric number x as 2. What did you get? You get a steric number x as 2. Then what will be the shape? Will it be linear, or will it be triangular planar, or will it be tetrahedral? Can you tell it for me? Anyone who is willing to give the answer for this? Suppose I calculated that your x value is 2. Then in that case, what will be the shape of that molecule? So it's a very simple question to answer. So basically hybridization is the intermixing, or you can tell it as the mixing of atomic orbital for the formation of bond within the same atom. Okay. Yes, for the value of x as 2, the shape will be linear. Very good. If you find out that the x value is 3, then what will be the shape in that case? Okay. So can you tell it for 3 as well as 4 as well as 5? Yes, it is most probable that there is a presence of sp. Now it can change, it is not for sure, it depends upon the molecule that you are considering, but in most of the cases you will see that your linear shape is due to the sp mixing. Okay, and I hope in your ncrt we are given with this sp only, so you don't have to worry about the rest of the cases. So can you tell it? Yes, for for the case of x value as 3, it will be trigonal planar, which is due to sp2 hybridization. Then for x is equals to 4, it is tetrahedral, and the hybridization which is involved is your sp3. Got it? Can you tell me an example of your tetrahedral shape molecule? So we have methane in that series, then we have water in that series H2O, then we have your ammonia in that series which is NH3. So these are some few examples of your tetrahedral shape. Is it clear to all of you? Now, if that part is clear, now we can move on to the whisper, because if you see the molecules of tetrahedral shaped molecule, then you can clearly see the example of those molecules which have lone pair on the central atom. So if you consider the case of water molecule, there are lone pairs present. Then again in the case of ammonia molecule, we have the lone pair present on the central atom. Got it? Now the question arises, what is the effect of these lone pairs on the shape of the molecule? Will it remain the same, or will there be any change? Meaning that if you take a tetrahedral structure, it has a certain angle, a fixed angle, which is 109. Okay. Similarly, if you take the case of sp2 of your trigonal planar, again the angle is fixed there also, which is 360 by 3 or 120 degrees. Now I am saying that the presence of lone pair, will it have any effect on that shape? Will it change, or the angle will remain same? So that thing is discussed in this whisper theory overall. Got it? You got my point? What is the reason behind bringing the whisper theory into the picture? Any doubt till this point? Okay, now we shall move forward. So, hybrid orbitals and molecular shapes involving s, p, and d orbital. So, here is a total diagram for you. Okay, now suppose you calculated the x value as 2. Now, that means your shape will be linear, and there is only one case possible for that, which is presence of two bond pair, isn't it? So, that is the only case which is possible for the linear shape. There cannot be presence of a lone pair and a bond pair. Okay, so that is not significant. But as soon as you move on to the trigonal planar, we have two cases possible here. One is three bond pair, or we can have two bond pair and one lone pair. Got it? The value of x will be same for both of them. Take an example. Suppose I am calculating the value of x for BF3. So boron has total of how many electrons in the valence shell? It is 3, right? Now there are 3 valence electron for the boron. Got it? What is the number of monovalent atom? It is again 3. So 1 plus 3 plus 1 by 2 multiplied by 3 plus 3, that will give you 3, means the steric number is 3. So that is your first calculation. If you do it similarly for SO2, then here what will be the case? X will be equals to half multiplied by the number of valence electron. So for sulfur, the number of valence electron is 6. And what is the count of monovalent atom for this sulfur, for this given molecule SO2? Anyone? What is the count of monovalent atoms for the SO2 molecule? So just try to calculate the X value for this SO2 and tell me that what is the number of monovalent atom for this SO2 molecule. So please reply to this. Again, I am repeating my question. So we have a sulfur dioxide molecule. Can you tell me what is the value of X for this sulfur dioxide, and also tell me that where there is a whether there is a count of monovalent atom or not, and if yes, then what is the count? So monovalent atom is basically those surrounding atoms which has a valency of 1. Okay, simply 1. If you take the case of beryllium fluoride, the number of monovalent atom is 1, because fluorine is a monovalent atom as it forms one bond. Similarly, here also we have again fluorine, but here we have oxygen. Oxygen is something which is not monovalent in nature, it is divalent in nature. It forms two bonds. Therefore, the number of monovalent atoms in case of SO2 is 0. You got my point? Since oxygen is divalent in nature, it forms two bonds because it has a valency of 2, right? Therefore, the number of monovalent atoms in the case of SO2 will be 0. Is it clear to you? Any doubt till this? Did you get my point? Okay. So, we don't have any charge as cation or anion. We don't have any monovalent atom. Therefore, the formula will be half into 6, as simple as that, which is simply the number of valence electron. If you do so, the value of X will be 3 here, meaning that this molecule and this molecule both have the same value of X. Now, from here, we can predict the hybridization. If you got the value of X, we will predict the hybridization as sp2. So that is not the difficulty. The difficulty lies in the shape of the molecule, because while looking at the shape of the molecule, we do not look upon the lone pair. If you consider the Lewis structure of SO2, then the sulfur has 6 valence electrons, so it will share 2 of its valence electron with the oxygen and 2 of its valence electron with the another oxygen. But again, it will be left with one pair of electrons, and as a result of that, we will get a combination of 2 bond pair and 1 lone pair. Remember students, a double bond is counted as a single bond pair in the Vesper theory. Okay. Now, your sulfur is making 2 bonds with oxygen and another 2 bonds with the another oxygen. There is a total count of bond pair as 2, because we count a double bond in your Vesper theory as 1. Got it? Now there are 2 bond pair and 1 lone pair. That will result in a bent structure. Okay? You can just look for this structure. It is given there in the NCERT, the bent one. Now moving on to the next one. If you calculate the steric number for CH4, NH3, H2O, all of these will have the same steric number value, which is 4. So their hybridization will be same, which is sp3. But due to the variation of lone pair, we can have different cases. If all 4 are bond pair, then it will have a tetrahedral shape. If there is 3 bond pair and 1 lone pair, that will result in a pyramidal shape of the molecule. And if there are 2 bond pair and 2 lone pairs, then that will result in an angular or V shape. Remember, the shape is something in which we do not consider the lone pair. But if we talk about the geometry, suppose if someone asks you that what is the geometry of these molecules, then that will be same. Means the geometry of CH4, the geometry of NH3 and the geometry of H2O all will be same, and that will be your tetrahedral. But if I talk about the shape, then shape do not consider your lone pair. So keeping the lone pair aside, your CH4 has tetrahedral shape, NH3 has pyramidal shape, and your H2O has angular shape. Similarly, if I move on to the PF5, SF4, CLF3, then all of these molecules have the same steric number, which is equals to 5. But due to different combinations of lone pair, the first one, if you take PF5 or PCl5, there are no lone pairs. As a result of it, you will see a trigonal bipyramidal shape, which is due to sp3 dehybridization. Whereas in the case of SF4, it has one lone pair and 4 bond pair, and that results in a seesaw shape. But again, the geometry will be same for all of these, which are having the same hybridization, which is as trigonal bipyramidal. Okay. Similarly, you can look for IF7, which has pentagonal bipyramidal shape because it has 7 bond pair and the hybridization is sp3d3. Is it clear to all of you? Any doubt till this point? So we can move forward on to the last and the most important concept of the bonding in your molecule, which is the molecular orbital theory. This was given by Hund and Mulliken. Now, this is different from all other theories, where in the previous theories we were considering only the two nuclei and the interaction between the two nuclei for a bond formation. In the case of molecular orbital theory, we look upon the whole molecule as a single entity. Okay. Then how are they formed? So your molecular orbitals are formed by the linear combination of atomic orbital, and that results in two types. First is the bonding molecular orbital, which is represented as sigma or pi, and this makes the bond stronger. So if your electron goes to the bonding molecular orbital, your bonds become stronger, whereas your electron going to your sigma star or pi star makes your bond weaker and reduces the stability of the molecule. Now we have a diagram to represent the same. Remember, there are two possibilities. If you consider it for the B2, C2 and N2, the energy order starts from sigma to S, then we have sigma star to S, pi 2p, sigma 2p, pi star 2p and sigma star 2p. Whereas in the case of O2, F2 and Ne2, there is an interchange, right? You can clearly see here that after sigma star 2s, we have pi 2p for boron, carbon and nitrogen. But if you consider it for the O2, F2 and Ne2, the next energy, highest energy is sigma 2p. Got it? So you can clearly see that these two are exchanging their position. Means in the case of B2, C2 and N2, and in the case of hydrogen, helium also. Oh, okay. So in the case of hydrogen, helium, you don't have to worry about P. So it starts from the B2, C2 and N2 only. So for these three molecules, first your pi 2p is there and then your sigma 2p. But in the case of O2, F2 and Ne2, first sigma 2p is there and then pi 2p. So this is the difference. And after putting the orbitals, molecular orbitals, we put the electrons. For the case of boron, there are total of 6 electrons. So 1, 2, 3, 4, 5, 6. Rest of them are kept in the inner orbitals, which are your sigma 1s and sigma star 1s, which contains a total of 4 electrons. Here we are talking about only the valence electrons. Similarly, here if you see, then we have sigma 2s2, then sigma star 2s2, then we have pi 2p 4. Now you should remember this order, and you should also remember where this order is changing. So if I just write the electronic configuration for the case of O2 and F2, then it looks like this: sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, then sigma 2pz, pi 2px is equals to pi 2py, then comes your pi star 2px is equals to pi star 2py, and lastly your sigma star 2pz. But if you look that same for the Li2, B2, B2, C2 and N2, which is before your oxygen, then you will clearly notice that sigma 2pz comes after the pi 2px is equals to pi 2py. So this is the most important difference between these two kind of species. Is it clear to you? Now, once you are able to write the electronic configuration, molecular orbital electronic configuration, then you can easily calculate the bond order for the diatomic molecules or ions, which is given as number of electrons in the bonding orbital minus the number of electrons in the anti-bonding orbital divided by 2. So this gives your bond order. Got it? Now, if you find that your Nb is greater than Na, means the bond order is positive, then in that case your molecule will be stable. But if you see that your molecule is having Na greater than Nb, means there are more electrons in the anti-bonding orbital, or there are same number of electrons in the bonding and anti-bonding orbital, then it will result in a zero bond order or a negative bond order. Therefore, your molecule will not be stable. Next, then we have the bond strength. If the bond order is high, the bond strength will be high. After that, we have this magnetic behavior. So it is totally dependent upon the number of unpaired electron. If you take the case of O2, there are unpaired electron present there. So it will be a what? It will be a paramagnetic substance. Now, what are paramagnetic substance? So they have unpaired a pair of electron in their MOT, and that results in a magnetic behavior. Where in the case of all unpaired electron, we see that the molecule is diamagnetic in nature. You can just try to draw the MOT for hydrogen, and then there you will see that all electrons are paired up. Then there is a formula to calculate the magnetic moment with the help of the unpaired electron count. It is given as root under n into n plus 2 Bm. Here Bm is the unit of magnetism, which is Bohr magnetron, and your n is the number of unpaired electrons. Lastly, we will talk about the hydrogen bonding. So this is also very important. It is basically an attractive force which coagulates between the hydrogen, which is attached to an electronegative element, with the lone pair of another electronegative element. Remember, it is only possible when your hydrogen is bonded to fluorine, oxygen or nitrogen, and it is not possible for those hydrogens which are bonded to chlorine. Although your chlorine is having a same electronegativity as that of nitrogen, but due to the large size of chlorine, hydrogen bonding is not possible for those hydrogens which are attached to chlorine. It is only possible for those hydrogens which are attached with fluorine, oxygen and nitrogen. Specifically, if I take the case of HF, then it shows the strongest hydrogen bond. Now there are two types of hydrogen bonding. What are those? The first one is intermolecular hydrogen bonding, which occurs between the atoms of two different molecules. Here we can see an example of two HFs which are hydrogen bonded with each other. You can see that one fluorine of one molecule is hydrogen bonded with the hydrogen of other molecule of the HF. Now, this intermolecular hydrogen bonding, it results in an increase of boiling point due to high intermolecular forces, as well as the viscosity and the surface tension, whereas the volatility of the molecule decreases due to this high intermolecular forces between the molecules. Now, talking about the next type of hydrogen bonding, we have this intramolecular, which happens within the molecule. Now, as a result of this, all the things that are being increased in the case of intermolecular are now here decreased. Like your boiling point is decreased, your viscosity is decreased, your solubility is decreased if you are seeing a intramolecular hydrogen bonding, whereas the volatility increases. We can take the example of orthonitrophenol. So in the case of orthonitrophenol, intramolecular hydrogen bonding is possible because the hydrogen of the same molecule is interacting with the oxygen of that same molecule, which is of a nitro group. As a result of this, your orthonitrophenol is having a lower boiling point as compared to the paranitrophenol. We will talk about this in the organic as well, and it results in an increased volatility of this molecule. Okay. So this was all for the theory part. Next we will move on to the questions. Just wait for a while. So here is your first question. You have to tell the correct statement for the molecule CSI3. First is whether it is a covalent molecule or not. Then second option is it contains CS plus and I3 minus. Then the third one is it contains CS3 plus and I minus. And the fourth one is it contains CS plus I minus and lattice I2 molecule. So what will be the correct answer for this? Remember, cesium is a metal which can have only plus one oxidation state. Okay, it belongs to the same family to that of the sodium, right? So it can only show a plus one oxidation state and it is a metal. So what will be the answer? The correct answer to this question will be it contains CS plus and I3 minus. How do we come on to this? So if you consider the I3 minus, it is an ion which is made up of I2 and I minus which has linear shape. While in case of CS plus, it is an alkali metal cation. Okay, so the correct answer will be option B and not D. Next question. Bond order normally gives idea of stability of a molecule or species. All the molecules like your H2, Li2 and B2 have the same bond order, yet they are not equally stable. Their stability order is, so how do you decide the stability? You simply calculate the bond order of these molecules to compare their stability. So if that is the way, how what is the stability order? Which one is correct? Can you calculate it? Anyone who is willing to give the answer? So what will be the order of stability for the given molecule? You simply have to calculate the bond order and see which one has the highest bond order, and that one will be the most stable one. Okay, so let us move on to the answer. The correct answer will be H2 Li2 and then after B2. How we'll see it? To, to look upon that, we have to see the molecular orbital configuration for the given species. If you consider it for H2, it is sigma 1s2, right? Then for lithium, 2 it is sigma 1s2, sigma 1s, then sigma star 1s2, then we have sigma 2s2. Further, for the boron, it is sigma 1s2, sigma star 1s2, then sigma 2s2, sigma star 2s2. Finally, we have pi 2p x1 is equals to pi 2p y. You can clearly see that the number of anti-bonding electrons is increasing, and that would result in an increased energy and decreased stability. So from that point of view, H2 has no anti-bonding electron, so it is the most stable one. Then for Li2 we have 2 anti-bonding electron, and for the B2 we have 4 anti-bonding electron, hence it has the lowest stability. You can also calculate the bond order. So for hydrogen it will be 1. If you calculate it for the next one, then again it will be 1 for the lithium too. Then what about the boron? For boron, if you calculate, so 2 plus 2 4, 4 plus 1 5 1 6, and 6 minus 4, which will be 2, and 2 by 2 again 1. So the bond order is equal in all of them. Basically, here the number of anti-bonding electrons is decreasing the stability, which is increasing from hydrogen to lithium and from lithium to boron. Moving on to the next question. Which of the following compounds has the smallest bond angle in its molecule? So you have H2O here, you have H2S here, NH3 and SO2. How do you decide it? Which is having the smallest bond angle? So for that, first we look upon the hybridization. Each of them, remember, each of them is having the same hybridization. You can just count it, it's very easy. Apart from SO2, each of them is having the same hybridization. Only SO2 is one which is having a different hybridization. Now, if this is the case, then how do you decide that which one will have your smallest bond angle? So that thing is decided by the S character of the hybridization. Suppose if I take the case of SO2, so SO2 has a sp2 hybridization, which means there is 33% S character and 66% P character. Whereas in the case of NH3, H2S and H2O, the S character is 25% and the P character is 75% due to their sp3 hybridization. Now, since the S character increases, the bond angle decreases. Remember, it is a very important statement that bond angle is directly proportional to the S character. Therefore, we have three candidates here which are having the same S character, that is for H2O, H2S and NH3. The question now asks you that which one will have the smallest bond angle out of these three. SO2 is already eliminated in this race. To consider that, we have to now look upon the number of lone pairs. So the number of lone pairs is highest for H2O and H2S, as they have the same count of the monovalent atom and the valence electron. NH3, which is having one lone pair, of course it will be again eliminated. So now ammonia and SO2 are eliminated and we are left with this H2O and H2S. Got it? Next thing we have to look upon is the size. Okay, is the size of the molecule. It is seen that your H2S will have the smallest bond angle. Let's see what is the reason behind it. So basically, due to the bond angle of because S atom is large in size and it has low electronegativity. Okay, because the sulfur is large in size and it has low electronegativity. As a result of that, it will have what? It will have the smallest bond angle. Is it clear to you? Any doubt till this point? Okay, now we shall move forward. Next question. Arrange the following molecule in the increasing order of bond angle. So we have H2O, then we have H2S, then H2Se and H2Te. Now in this question, you have to simply look upon the bond angle order, and that is decided by the central atom. Because the surrounding atom is same, the number of valence electron is same. Got it? How do we decide it? So the correct answer is 4, 3, 2, 1. To decide this, you have to look upon the size of the central atom. So basically, due to the least electronegativity of H2Te and minimum in H2O due to high electronegativity of oxygen, it is seen that the first one will have the highest bond angle, then comes your 2, then comes your 3 and then comes your 4. So this is totally dependent upon the central atom. As we move down the group in a given series, then the bond angle decreases. So oxygen comes first, so it has the highest bond angle. Then comes your next one, which is sulfur, then comes your selenium and then comes your tellurium. So remember this, if the surrounding atoms are same and the central atom is changing and those are the participants of the same group, then down the group bond angle decreases. Got it? Moving on to the next question. Consider the following iodides. We have Pi3, ASI3, and SBI3, and these are the corresponding bond angles. Now, the bond angle is maximum in Pi3 if you see. And why is it possible? Why the bond angle is maximum here? So, four options are given here. Due to small size of phosphorus, then due to more bond pair repulsion in case of Pi3, and third is due to less electronegativity of phosphorus. Then fourth is none of the above. So we have seen the same type of question earlier. How do we answer this question? Very simple. So P is more electronegative among the given options. So due to this, there is more bond pair repulsion. Okay. Moving on to the next question. Here we have to decide the bond energy for HH, HF, FF, and it is given as 104, 38, and 135 kilocalorie per mole. The resonance energy in HF molecule will be, options are 142, 66, 72.14, and 79.26. So all are again given in kilocalorie per mole. So there is a very simple formula to calculate it. If you know this, you can easily calculate it as 72.14 kilocalorie per mole. The formula goes as, the resonance energy is equals to delta HF, which is represented as delta HF bond energy of HF minus root under bond energy of H2 into bond energy of F2. So in this way you can calculate the resonance energy. If you put the values here, so 135 minus root under 104 into 38, and further it is 135 minus 62.86, it comes out to be 72.14 kilocalorie per mole. So this was all for today's lecture. Thank you for joining the session. I hope you enjoyed it.
Hello student. So in today lecture we will discuss the theory of matrices, right? So this is our disclaimer. So this is a trend analysis of previous 5 year question. So see that the weightage of this chapter is 2.77%, and this is a yearly distribution, yearly question distribution. So you can see that in year 2024 there is one question from this topic, right? Based on the inverse of matrices, and difficulty level is average. And in year 2023 there is a two question from this chapter based on the algebra of matrices, right? And in year 2022 there is a two question from this topic based on the multiplication of matrices and invertible matrices, right? And in year 2021 there is a one question from this chapter based on the multiplication of matrices, right? And difficulty level is average. So this is our index. So first we will discuss that what is a matrix, right? Then in the definition of matrices we will see that what is the order of a matrix and what is the row and column matrices, right? And then we will discuss the type of matrices, and then we will talk about the equality of matrices. For example, if you are given two matrices, then how will you know, or what is the condition for two matrices to be equal, right? We will discuss that. And then we will discuss the algebra of matrices, and then finally we will provide a summary of whatever we discussed. So let's start with the definition of a matrices. What is the matrix? So a matrix is an arrangement of a number in row and column, right? So a matrix is basically a rectangular arrangement of a number in the form of row and column. So if you have a matrix with m row and n column, then we call that matrix a matrix of order m cross n, right? So that is, if the number of row in a matrix is m and the number of column is n, then the order of the matrix will be m times n, right? And if you have a matrix of order m cross n, then the number of element in this matrix will be mn, right? So let's suppose we have a matrix of order 2 cross 3. So what will the number of element in that matrix? So the number of element will be m times n, means 2 times 3, which is equals to 6, right? So this is a general form of an m cross n matrices. Then a equals to a11, a12, a13 dot a1n, then a21, a22, a23 dot a2n. Then we have am1, am2, am3 dot amn. So here a11 is the element of first row and first column, right? And a12 is the element of first row and second column, and a13 is the element of first row and third column. Similarly, a1n is the element of the first row and nth column, right? And similarly, a21 is the element of second row and first column, and a22 is the element of second row and second column, and a23 is the element of second row and third column, and a2n is the element of second row and nth column, right? Similarly, we can say that am1 is the element of mth row and first column, am2 is the element of mth row and second column, am3 is the element of mth row and third column, amn. Amn is the element of mth row and nth column, right? So this is a general form of a matrix of order m cross n. So now we are going to see that some important terms related to matrices. So the element in the ith row and jth column is denoted by aij, right? So let's suppose I'm saying that a21. What is the meaning of a21? A21 is the element in second row and first column, right? And similarly, let's suppose I'm saying that a23. What is the meaning of a23? A23 is the element in the second row and third column. So the element a11, a22, a33 are called the diagonal element. We know that the element in the ith row and jth column is denoted by aij, right? So if we set I equals to j, so that will be a11, right? So if we have I equals to j, so we say that that element is the diagonal element, right? So a11 means the element in the first row and first column, a22 means the element in the second row and second column, a33 means the element in the third row and third column, right? So these are the diagonal element, right? Because here we have I equals to j, right? I is the row and j stands for column, right? And the line along with the diagonal element lie is called the principal diagonal, or simply the diagonal of the matrices, right? So now we are going to discuss the type of the matrices. Now the first type of matrices is null matrix or zero matrix. So if all element of a matrix are zero, so in that case we will say that that matrix is null or zero matrix, and it is denoted by capital O, right? So let's suppose you have a 2 cross 2 matrix, right? Where we know that 2 cross 2 matrix, we can write this as a11, a12, a21 and a22, right? And let's suppose all the element of the matrix are zero. It means that let's suppose the value of a11, a12, a21 and a22 are zero. So in that case we will say that this is a zero matrix of order 2 cross 2, right? So if you have any matrix and all the element of that matrix is zero, so we will say that that matrix is null or zero matrix, right? So now we talk about the row matrix and column matrix. So a row matrix is a matrix that has only one row and can have any number of column. That is, if you have a matrix in which the number of row is 1 and the number of column can be anything, then we will call that matrix is a row matrix, right? So now let's talk about a column matrix. So just as the number of row should be 1 in a row matrix, similarly the number of column should be 1 in a column matrix, right? And the number of row can be anything, right? So a matrix in which the number of column is 1 is called a column matrix, right? So here we have discussed that what is a column matrix and what is the row matrix. Now let's talk about a square matrix. So if in a matrix the number of row and the number of column are equal, then we say that that matrix is a square matrix, right? So we will denote that square matrix A equals to aij n cross n, then it is known as a square matrix of order n, because here we have n cross n, the number of row and the number of column are equal, that is n. So that's why, so if we have any matrix where the number of row and the number of column are equal, so we will say that that matrix is a square matrix. And if in a matrix the number of rows is less than or greater than the number of column, then it is called a rectangular matrix. Or we can say that if the number of row and the number of column are not same, right? So in that case we will say that the matrix is a rectangular matrix, right? And if in a square matrix all the non-diagonal element are zero, so it is called a diagonal matrix, right? So let's suppose you have a matrix of order 2 cross 2, right? So we will denote the matrix of order 2 cross 2 A equals to a11, a12, a21 and a22. and here all the non-diagonal element are 0. So we know that a11 and a22 are diagonal element, and a12 and a21 is non-diagonal element. So let's suppose the value of a11 a12 and a21 equals to 0. So we can write a equals to a11 0 0 a22, right? So we will say this matrix is the diagonal matrix, right, of order 2, right? So if you have any matrix, if you have any square matrix and all the non diagonal element are 0, so in that case we will say that that matrix is a diagonal matrix. So now we are going to discuss the scalar matrix. So if in a square matrix all non diagonal element are 0 and diagonal element are equal, then it is called a scalar matrix, right? So let's suppose you have any matrix where all the non-diagonal element are 0 and the diagonal element are equal, right? So then we'll say that that matrix is a scalar matrix. So let's suppose you have a matrix of order 2 cross 2, right? So we'll say that that matrix A equals to a11 a12 a21 and a22, right? And what is the condition for scalar matrix? The condition for scalar matrix is all non-diagonal element are 0 and the diagonal element are equal, right? So let's suppose a21 and a12 are 0 and the value of a11 and a22 is same. So in that case we will say that that matrix is a scalar matrix of order 2 cross 2, right? So now we will discuss that what is the difference between diagonal matrix and the scalar matrix. See that in the diagonal matrix there is only one condition. What is that? All non-diagonal element are 0, right? But the diagonal element cannot be equal. Let's suppose the diagonal element we have a11 equals to 1, a22 equals to 2, a33 equals to 3, right? So this we say that this matrix is a diagonal matrix, but we cannot say that this matrix is a scalar matrix, right? Because for scalar matrix we have a one more condition. What is that? The condition is that the diagonal element are equal, right? So if the value of a11 equals to a22 equals to a33, so in that case we can say that this matrix is a scalar matrix of order 3 cross 3, right? So from here what we can say? We can say that every scalar matrix is a diagonal matrix, but diagonal matrix need not be scalar, right? Diagonal matrix will be scalar if the diagonal element are 0, right? So now we are going to discuss that what is a unit matrix. So if in a square matrix all non-diagonal element are 0 and diagonal element are unity, then we say that that matrix is a unit matrix or identity matrix, right? And we denote the identity matrix of order n by in, right? And when order is clear from context, then we simply write it as I, right? So see that what is a scalar matrix? A scalar matrix is that if we have any square matrix where the non-diagonal element are 0 and the diagonal element are equal, so we will say that that matrix is scalar matrix. And what is a unit matrix? The unit matrix is that all the non-diagonal element are 0 but the diagonal element should be 1, right? So let's suppose we are considering the 3 cross 3 matrix A equals to, so we will have a a11 0 0 0 a22 0. So this is a 3 cross 3 diagonal matrix, so 0 0 a33, right? So see that we'll say that this is a diagonal matrix and this will be scalar matrix if a11 a22 equals to a33, but this will be unit matrix if a11 equals to a12 a22 equals to a33, that is equals to 1. In that case we will say that this matrix is a unit matrix. So we can say that a unit matrix is a scalar matrix, right? And unit matrix is also a diagonal matrix, right? But we cannot say that scalar matrix is a unit matrix, right? Because let's suppose you have any matrix of order 2 cross 2, A equals to 2 0 0 2. So this is a scalar matrix. Why? Because here the non-diagonal element are 0 and the diagonal element are equal, that is 2. So this is a scalar matrix, but this is not a unit matrix. Why? Because for unit matrix the diagonal element should be 1, but here the diagonal element are 2 and 2, right? So that's why we can say that a unit matrix is a scalar matrix, but scalar matrix need not be a unit matrix, right? Now we are going to see that what is the upper triangular matrix and what is the lower triangular matrix. So in a square matrix, if aij equals to 0 for I greater than j, then it is called an upper triangular matrix. It means that if we have any matrix where the element below the diagonal or 0, so in that case we will say that that matrix is a upper triangular matrix, right? And for the lower triangular matrix we have given that aij equals to 0 for I less than j, right? It means that if we have any matrix where the element above the diagonal or 0, so in that case we will say that that matrix is a lower triangular matrix, right? So let's suppose we have a given square matrix. So for upper triangular matrix the element below the diagonal should be 0, and for a lower triangular matrix the element above the diagonal should be 0, right? So please note that the diagonal element of a diagonal matrix may or may not be 0, right? So here we have discussed that what is a scalar matrix, what is a unit matrix, and then we have discussed that what is a upper triangular matrix and what is a lower triangular matrix. So now we are going to discuss that when we will say that two matrices are equal. So let's suppose we have a true matrix A and B are said to be equal if they are of same order and all the corresponding element are equal, right? It means that the order of this matrix A and B should be same and the corresponding element should be same. In that case we will say that these two matrix A and B are equal, right? And now we are going to discuss the algebra of matrices. So let's suppose we have a matrix A of order m cross n, and we have another matrix B of order m cross n, right? So this is the two matrix of same order. Then A plus B equals to aij plus bij, and the order of A plus B is also m cross n, right? How? So let's suppose we have a matrix A of order 2 cross 2, that is A equals to a11, then a12, a21, a22, right? And we have another matrix B of order 2 cross 2. Let's suppose we have a B equals to b11, b12, b21, b22, right? So the value of A plus B will be a11 plus b11, right? Because we just need to add the corresponding element, right? So A plus B equals to a11 plus b11, right? Then a12 plus b12, and then a21 plus b21 and a22 plus b22, right? So this will be the value of A plus B, right? So you just need to add the corresponding element, right? And similarly if you will calculate the value of A minus B, so the value of A minus B will be a11 minus b11, a12 minus b12, a21 minus b21, and then a22 minus b22, right? So in A minus B you just need to take the difference of the corresponding element, right? And in addition you just need to add the corresponding element, right? So if we have any matrix A and B, so we can calculate the value of A plus B and A minus B, right? So where the value of I equals to 1 to dot 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 m, and the value of j equals to 1 to dot 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 n, right? So if we have a matrix A equals to aij be an m cross n matrix and k be any scalar, then k times A equals to kij, right? It means that we just need to multiply by the scalar on each and every element of the matrix, right? And if we have a matrix A equals to aij of order m cross n, and we have another matrix B of order n cross p. Be any two matrices such that the number of column of A is equals to the number of row of B. Then the product of these two matrices A and B, we can write A times B equals to Cij, and the order of this matrix will be m cross p, where we can calculate the value of Cij using the formula summation k equals to 1 to n aik times bkj, right? And see that here in a matrix A, right, what is the number of column? The number of column is n. And in a matrix B, what is the number of row? The number of row is n also, right? So here the number of column in A is equals to the number of row in B, right? So that's why we can multiply these two matrices, right? So if the number of column in A is not equal to the number of row in matrix B, so in that case we cannot multiply these two matrices, right? So for multiplication, the number of column in A should be equal to the number of row in the matrix B, right? So now we are going to discuss the some important property. So this is known as the commutative property of addition. So let's suppose you have a two matrix A and B, right? So A plus B equals to the B plus A, right? Because let's suppose you have a matrix A equals to of order 2 cross 2, and B also you have matrix of order 2 cross 2. So let's suppose A equals to A11, A12, A21, A22, right? And you have a matrix B equals to B11 plus B12, B21 and B22, right? So we have discussed that how to calculate the value of A plus B. So to calculate the value of A plus B, we just need to add the element of the matrix A to the corresponding element of the matrix B. So that's why the value of A plus B will be A11 plus B11, A12 plus B12, right? And A21 plus B21 and A22 plus B22, right? So this is the value of A plus B, right? So similarly we can calculate the value of B plus A. So the value of B plus A will be B11 plus A11, B12 plus A12, B21 plus A12 and B22 plus A22, right? So this is the value of B plus A, and we know that A11 plus B11 equals to the B11 plus A11, right? And A12 plus B12 equals to the B12 plus A12, right? And A21 plus B21 is equals to the B21 plus A21, and A22 plus B22 is equals to the B22 plus A22, right? So since the all the elements are equal, right? So that's why we can say that these two matrices are equal. So that's why we have A plus B equals to B plus A, right? And now we are going to discuss the next property. This is the associative property of addition. So when we will add A plus B plus C, so this will equals to A plus B plus C, right? So this is known as the associative property of addition, right? And the third property is that alpha times A plus B is equals to the alpha A plus alpha B, where alpha is any scalar, right? And then the fourth property is that alpha plus beta times A equals to the alpha A plus beta A, right? And this is a fifth property, that is alpha times beta A equals to the alpha beta times A, where alpha and beta are any scalar, right? And the sixth property is that AB times C equals to the A times BC. This is known as the associative property of multiplication, right? And then the seventh property is that A times I equals to A equals to I times A. Here I is the identity matrix, right? So let's suppose we have A is the matrix of order 2 cross 2, right? And I is also the matrix of order 2 cross 2. So we can write A as A11, A12, A21, A22, right? So and we can write I equals to 1 0 0 1, right? Because we know that in identity matrix all non-diagonal element are 0 and the diagonal element should be 1. So that's why we can write I equals to 1 0 0 1, right? And when we'll multiply ai means a11, a12, a21, a22 times 1 0 0 1, right? So we will get a11, a12, a21 and a22. So we know that this is the matrix A. So that's why we can say that ai equals to a equals to ia, right? So similarly when we will calculate ia means let's suppose a is the matrix of order 2 cross 2 and I is also identity matrix of order 2. So we can write ia equals to 1 0 0 1 times a11, a12, a21, a22. So when we'll multiply these two I and a, so we will get that a also means we will get a11, a12, a21 and a22, right? So now we can say that ai equals to a equals to I times a, right? And now we are going to discuss the next property. This is known as the distributive property. What is that? So a times b plus c equals to the a times b plus ac, right? So this is known as the distributive property. And also note that we can write a square equals to a times a. Similarly we can calculate the value of a cube equals to a times a times a, which is equals to a squared times a की power 1, right? So similarly we can calculate any power of the matrix A. So if the product AB is possible, right, it means that if we can calculate the product AB, so then it is not necessary that the product BA is also possible, right? And also it is not necessary that AB equals to BA, right? So it means that if we have a two matrix A and B and we can calculate what is the value of AB, so it is not necessary that we can also calculate the value of BA, right? And let's suppose if we can calculate the value of AB and BA also, so in that case it is not necessary that AB equals to BA, right? And the last point is that the product of two non-zero matrices can be zero. So let's suppose I am taking the matrix as A equals to 1 2 2 4 and the matrices B equals to 2 -1 -1 and 0.5, right? So when we will calculate A times B, so what we will get? When we will calculate A times B, so we will get AB equals to 2 -2 and then we will get 1 -1 and then we will get 4 -4 and then we will get -2 plus 2, right? So this will equals to 0 0 0 0, right? So we can say that the product of two non-zero matrices can be a zero matrices, right? So it is not necessary like if A is non-zero and B is non-zero, so if you will take the product of AB, so it will also non-zero. No, it is not necessary. So if A is the non-zero matrices and B is also non-zero matrices, so AB can be zero matrices, right? Now we are going to see the summary of this chapter. So now we are a matrix. What is a matrix? A matrix is an arrangement of a number in row and column, right? And a matrix having m row and n column is called a matrix of order m cross n, and the element and the number of element in this matrix will be mn, right? So if you have a matrix with m row and n column, so then its order becomes m cross n and the total number of element will be m times n, right? And this is a general form of m cross n matrices, right? A equals to a11, a12, a13 dot a1n, then a21, a22, a23 dot a2n, then we have am1, am2, am3 and amn, right? And we know that a11 is the element of first row and first column, A12 is the element of first row second column, A13 is the element of first row and third column, and A1n is the element of first row and nth column, right? And A21 is the element of second row and first column, and A22 is the element of second row and second column, and A23 is the element of second row and third column, and A2n is the element of second row and nth column, right? So and am1 is the element of mth row and first column, am2 is the element of mth row and second column, am3 is the element of mth row and third column, and dot 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 amn is the element of mth row and nth column, right? And we know that the element in the ith row and jth column is denoted by aij, right? So let's suppose I am taking A23. So what is the meaning of A23? A23 meaning that this is the element of ith row and jth column, and the element A11, A22, A33 are called the diagonal element, right? Where the row and column are equal, right? So that element is called a diagonal element. And then the line along with the diagonal element lie is called the principal diagonal, or simply we can say that the diagonal of the matrices, right? And also we have discussed that if all element of a matrix are 0, so in that case we will say that that matrix is a null matrix or 0 matrix, right? And it is denoted by capital O, right? And a matrix which has only one row and any number of column is called a row matrix, right? And similarly, if we have a matrix, it has only one column and any number of row, then it is called a column matrix, right? So let's suppose we have a matrix in which we have only one row and n column, so we'll say that this matrix is a row matrix, right? And let's suppose we have a matrix where we have a one column and n row, so we will say that this matrix is a column matrix, right? And if in a matrix the number of row and the number of column are equal, so in that case we will say that that matrix is a square matrix, right? And we will denote that matrix A equals to aij, where order of this matrix will be n cross n, means the number of column equals to the number of row, which is equals to n, right? And then it is known as a square matrix of order n, right? And then we have discussed that if in a matrix the number of row is less than or greater than the number of column, so in that case we will say that that matrix is a rectangular matrix, or a matrix in which the number of row is not equal to the number of column, we will say that that matrix is a rectangular matrix, right? And we have discussed that if in a matrix all the non diagonal element are 0, so in that case we will say that that matrix is a diagonal matrix, right? And then we have discussed that if in a square matrix all non diagonal element are 0 and diagonal element are equal, so in that case we will say that that matrix is a scalar matrix, right? And we have discussed that every scalar matrix is a diagonal matrix, but diagonal matrix need not be scalar matrix, right? Because for scalar matrix there should be one more condition. What is that? The diagonal element are equal, but in the diagonal matrix there is only one condition. What is that? All the non diagonal element are 0, right? And then we have discussed that if in a square matrix all non diagonal element are 0 and the diagonal element are unity, so in that case we will say that that matrix is a unit matrix or identity matrix, right? And we denote the identity matrix of order n by in, right? Where when order is clear from the context, so we can simply write this matrix as a I, right? And also we have discussed that unit matrix is a scalar matrix, but scalar matrix need not be a unit matrix. Why? Because for a unit matrix the diagonal element should be equal, but the diagonal element should be 1, right? But for a scalar matrix it is not necessary. There is only one condition. What is that? The diagonal element should be equal and all the non diagonal element are 0, right? So we can say that unit matrix is a scalar matrix, but scalar matrix need not be a unit matrix, right? So you can take an example. Let's suppose we have a any matrix of order 2 cross 2, A equals to 2 0 0 2. So this is a scalar matrix, right? Because the diagonal element are equal, that is 2. But this is not a unit matrix. Why? Because here the diagonal element are not 1, it is 2, right? And let's suppose you are taking a matrix of order 2 cross 2, A equals to 1 0 0 1. So we can say that this is a unit matrix because the diagonal element are 1, and also we can say that this is a scalar matrix because the diagonal element are equal, that is 1. So that's why we can say that the unit matrix is a scalar matrix, but scalar matrix need not be unit matrix. And we have discussed that in a square matrix, if aij equals to 0 for I greater than j, then it is called an upper triangular matrix, right? It means that the element below the diagonal element are 0 in the case of upper triangular matrix. And if aij equals to 0 for I less than j, then it is called a lower triangular matrix. It means that the element that is above the diagonal element is 0. So in that case we will say that this matrix is a lower triangular matrix. So note that the diagonal element of a diagonal matrix may or may not be 0, right? So wait a student, now we are going to discuss the some question based on the theory which we have discussed so far. So wait for 1 minute. So now student, we are going to discuss some practice question based on the theory which we have discussed. So this is our disclaimer part. So this is our index. We are going to discuss the practice question. So the first question is that if we have given the matrix A of order 2 cross 2, that is 0 1 1 1, and also we have given the matrix B of order 2 cross 2, that is 0 minus 1 1 0, right? Then we need to find which of the following is correct, right? We have a given four option. So the first one we have given that A plus B times A minus B equals to A square plus B square, and second we have given A plus B times A minus B equals to the A square minus B square, and the third one we have given A plus B times A minus B equals to I, and then the fourth one we have given none of these, right? So please try to solve this student, then we will discuss that. Yeah, so please try. So let's discuss the solution. So correct answer is D. Yes, very good, BK. So let's start the solution. Let's see that how D will be true. So here we have given the matrix A of order 2 cross 2, that is 0 1 1 1, and also we have given the matrix B of order 2 cross 2, that is 0 minus 1 1 0, right? So A plus B equals to the 0 1 1 1 plus 0 minus 1 1 0. So here I have just put the value of A and B, right? So A plus B equals to the 0 0 2 1. How? Because we know that if you have a two matrices and we want to find what will be the sum of that two matrices, so how we can find? We just need to add their corresponding element, right? So see that A plus B will equals to 0, means A11 plus B11, right? And A11 we have 0, and also we have B11 equals to 0, so we can write this at 0 plus 0, right? And what will be the value, next value? See that the next value will be A12 plus B12, and we have given that the value of A12 equals to 1 and B12 equals to minus 1, right? So A12 plus B12 equals to 1 minus 1, that is equals to 0, right? And next, now we are going to see that the next element. So the next element will be A21 plus B21, and here we have given that the value of A21 equals to 1, and also we have given the value of B21 equals to 1, right? So A21 plus B21 will equals to 1 plus 1, that is 2, right? And now we are going to see the next element. So the next element will be A22 plus B22, and we have given the value of A22 equals to 1 and the value of B22 equals to 0, right? So 1 plus 0 equals to 1, right? So that's why the value of A plus B will be 0 0 2 1, right? So to calculate A plus B, now you just need to add their corresponding element. So now we are going to calculate what will the value of A minus B. So we have given that A equals to 0 1 1 1 and B equals to 0 minus 1 and 1 0, right? So A minus B will be, we just need to take the difference of the corresponding element, right? So the first element will be A11 minus B11, and we have given that A11 equals to 0 and B11 is also 0, so that's why A11 minus B11 will be 0, right? And the next element will be A12 minus B12, right? And we have given that A12 equals to 1 and we have given that B12 equals to minus 1, so 1 minus minus 1, so that will equals to 1 plus 1, so that will equals to 2, right? And now we are going to calculate the next element. So the next element will be A21 minus B21, right? And here we have given the value of A21 is 1 and also we have given that the value of B21 is 1, so that's why A21 minus B21 will equals to 1 minus 1, that is equals to 0, right? And the last element will be A22 minus B22, right? And we have given the value of A22, that is 1, and also we have given that the value of B22 equals to 0, so that's why A22 minus B22 will equals to 1 minus 0, that is 1, right? So that's why the value of A minus B will be 0 2 0 1, right? And now we are going to calculate the value of A square, and we know that A square equals to A times A, right? So to calculate the A square, we just need to multiply the matrices A by itself, right? So that means 0 1 1 1 times 0 1 1 1, right? See that. So the A square will be, we just need to multiply the first row by first column, right? So the first row of A is 0 1 and the first column is 0 1 also. So when we'll multiply these two, so what we'll get? 0 times 0 plus 1 times 1, that is equals to 0 plus 1, right? Now we are going to calculate the next element. So the next element we can calculate, we need to multiply 0 1 by 1 1, right? So when we'll multiply these two, means the first row and the second column, right? So we will get 0 plus 1 times 1, that is 0 plus 1, right? So now to calculate the next element, we are going to multiply the second row of the matrices A to the first column of the matrices A, that is we are going to multiply 1 1 by 0 1. So what we will get? We will get 1 times 0 plus 1 times 1, that is equals to 0 plus 1, right? And now we are going to multiply the second row by second column, that is 1 1 by 1 1. So what we will get? 1 times 1 plus 1 times 1, that is 1 plus 1, right? So the value of A square will be 1 1 1 2, right? So here we have calculated the value of A plus B, and also we have calculated the value of A minus B, and we have calculated the value of A square, right? And similarly the value of B square equals to B times B, right? And it means that we just need to multiply the matrix B by itself, that is 0 minus 1 1 0 times 0 minus 1 1 0, right? So for that we just need to multiply the first row by the first column, that is 0 minus 1 by 0 0 and 1. So what we'll get? 0 times 0 plus minus 1 times 1. So it means that this will equals to 0 minus 1, that is equals to minus 1, right? And now we are going to multiply the first row by second column, that is 0 minus 1 to minus 1 0. So what we will get? 0 times minus 1 plus minus 1 times 0, right? So this will equals to 0 plus 0, right? So this will equals to 0, right? So that's why the second element is 0. So now we are going to calculate the next element of B square. So for that we just need to multiply this 1 0 by 0 1. So what we will get? 1 times 0 plus 0 times 1, that is equals to 0, right? And then we need to multiply this 1 0 by minus 1 0. So what we will get? 1 times minus 1 plus 0 times 0. So that will equals to minus 1 plus 0. So that will equals to minus 1, right? So here we have calculated the value of B square, that is minus 1 0 0 and minus 1. So see that we have calculated the value of A square, and also we have calculated the value of B square, right? So we are going to add the value of A square plus B square, right? So the value of A square is 1 1 1 2, and the value of B square is minus 1 0 0 minus 1, right? So we need to add this. So how we can add? We just need to add the corresponding element. It means that it is equals to 1 minus 1, which is equals to 0. So the first element will be 0, right? And then 1 plus 0, it means that 1, right? And the next element should be 1 plus 0, that is equals to 1. And then last element is 2 plus minus 1, this is equals to 2 minus 1, this is equals to 1, right? So that's why A square plus B square equals to 0 1 1 1, right? So similarly we can calculate the value of A square minus B square, right? Because we have the value of A square and also we have the value of B square, we just need to take the difference of the corresponding element, right? So the A square is 1 1 1 2 and B square is minus 1 0 0 minus 1, right? So we just need to take the difference of the corresponding element, right? So that's why the first element will be 1 minus minus 1. It means that 1 plus 1, it is equals to 2. So that's why the first element is 2. So now we are going to calculate the next element. So the next element will be 1 minus 0, this is equals to 1. So that's why the next element is 1, right? And then the next element is, we just need to take the difference of the corresponding element, means that A to 1 minus B to 1. So A to 1 is 1, B to 1 is 0. So 1 minus 0 is equals to 1, right? And now we are going to calculate the last element, that is A22 minus B22. A22 is equals to 2 and B22 we have minus 1. So 2 minus minus 1. So this is equals to 2 plus 1, right? So this is equals to 3, right? So that's why the value of A square minus B square will be 2113. So here we have calculated the value of A square plus B square, and also we have calculated the value of A square minus B square, right? And A plus B times A minus B. So we have the value of A plus B, that is 0 0 2 1, and also we have the value of A minus B, that is 0 2 0 1, right? So when we'll multiply these two matrices, so we just need to multiply the first row by the first column of the A minus B, means we just need to multiply the first row of A plus B to first column of A minus B. So we will get 0 times 0 plus 0 times 0, that is equals to 0 plus 0, right? And to calculate the next element, we just need to multiply the first row of A plus B to second column of A minus B, right? So that means that we need to multiply 0 0 by 2 1, right? So we will get 0 times 2 plus 0 times 1, that is equals to 0 plus 0, right? And now to calculate the next element, we need to multiply the second row of A plus B by the first column of A minus B, right? So we will get 2 times 0 plus 1 times 0, this is equals to 0 plus 0, right? And to calculate the last element, we just need to multiply the second row of A plus B by the second column of A minus B, right? So we will get 2 times 2 plus 1 times 1, that is equals to 4 plus 4, right? And when we will add this, so we will get the value of A plus B times A minus B equals to 0 0 0 5, right? So clearly you can see that A plus B times A minus B is not equals to A square minus B square, and also it is not equals to A square plus B square, and also it is not equals to I, right? So that's why we can say that the correct option is D, means none of these. So now we are going to solve the next question. In this question we have given that if P, Q, R are three real number satisfying the matrix equation, that is we have given two matrix. The first matrix we have given that PQR times the second matrix we have 3 4 1 3 2 3 2 0 2 equals to the matrix 3 0 1, right? So we need to find that what will the value of 2p plus q minus r, right? So first please try to solve this, then we will discuss the solution. Yeah, please try to solve this. Let's start the solution. Let's see that how we can find the value of 2p plus q minus r. So the correct answer is A, right? So now we will see that how the correct answer will be A, right? So now we will see its solution, right? So we have given that this matrix equation, that is p q r times, we have given the matrix 3 4 1 3 2 3, then 2 0 2 equals to the another matrix, that is 3 0 1, right? Then we need to find the value of 2p plus q minus r, right? So for that, see that the first matrix is the matrix of order 1 cross 3, means that we have a 1 row and 3 column, right? And the second matrix is that we have a matrix of order 3 cross 3, right? So when we will multiply these two matrix, so we will find another matrix of order 1 cross 3, right? It means that after multiplication we will find a matrix such that in that matrix we have a 1 row and 3 column, right? So let's see that how we can multiply these two matrix. So first we will multiply the first row of the first matrix with the first column of the second matrix, right? It means that we'll multiply p q r by 3 3 2, right? And then we just multiply the corresponding element and then we will add. So what we will get? 3p plus 3q plus 2r, right? So this is the first element, right? And then we just need to multiply the first row of the first matrix to the second column of second matrix, right? So it means that we just need to multiply pqr by 420, right? So we just need to multiply the corresponding element and then we just need to add. So what we will get? 4p plus 2q plus r times 0 equals to 0, right? So the second element will be 4p plus 2q plus 0, right? And to find the third element, we just need to multiply the first row of the first matrix, that is pqr, by the third column of the second matrix, that is pqr by 132, right? We just need to multiply the corresponding element and then we need to add. So when we'll multiply p by 1, so we will get p, plus we'll multiply 3 by q, so we'll get 3q, plus we'll multiply r by 2, so we'll get 2r. So we'll get p plus 3q plus 2r, and it is given that it is equals to 301, right? So when we will solve this matrix equation, so we will find that this will equals to 3p plus 3q plus 2r, 4p plus 2q plus 0, and p plus 3q plus 2r equals to 301, right? And we know that if two matrices are equal, so in that case their corresponding elements should be equal, right? So what we can say? We can say that the first element of the first matrix equals to the first element of the other matrix, right? So it means that we can say that 3p plus 3q plus 2r equals to 3, right? And also we can say that 4p plus 2q plus 0 equals to 0, right? And also we can say that p plus 3q plus 2r equals to 1, right? So when we will solve this system of equation, so we will find the value of p equals to 1 and the value of q equals to -2 and the value of r equals to 3, right? So we have the value of p q r, so and we need to calculate what will the value of 2p plus q minus r. So this will equals to 2 times 1 minus 2 minus 3, right? So this will equals to 2 minus 2 minus 3. So since 2 and 2 will cancel out, so we will get the value of 2p plus q minus r equals to -3. So now we are going to discuss the other question. So in this question we have given a upper triangular matrix of order n cross n. So we need to find what will the minimum number of 0 is, and we have given a 4 option. So the option A is n times n minus 1 by 2, and option B is n times n plus 1 by 2, and the option C we have given 2n times n minus 1 by 2, and option D we have given that none of these, right? So please try to solve the student, then we will discuss the solution. Now let's start the solution. So the correct answer will be A. Now we will see that how the correct answer will be A, right? So let's look at the solution. We know that a square matrix A equals to Aij is said to be an upper triangular matrix. What is that? There is a one condition, Aij equals to 0 for I greater than j, right? It means that the element below the diagonal are 0. So now we are going to consider an upper triangular matrix. So here we have considered an upper triangular matrix A equals to 1, 2, 3, 0, 5, 6, 0, 0, 7 of order 3 cross 3. It is an upper triangular matrix. Why? Because the element that are below the diagonal are 0, right? So it means that A21, A31 and A32 are 0. So that's why this is an upper triangular matrix of order 3 cross 3, right? So here the number of zeros equals to 3, right? Because we have a 3 0, that is A21, A31 and A32, right? So the number of zeros equals to 3, and we can write 3 equals to 3 times 3 minus 1 by 2, right? Because the value of 3 times 3 minus 1 by 2 is equals to 3, so that's why we can write 3 as 3 times 3 minus 1 by 2. And here what is 3? 3 is the order of this matrix, right? So in general what we can say, in general we can say that the minimum number of zeros in an upper triangular matrix will be n times n minus 1 by 2, right? So here we have solved this question, and we have find that the minimum number of zero in upper triangular matrix will be n times n minus 1 by 2, where n is the order of the matrix, right? So now we are going to discuss the next question. So in this question we have given the matrix A equals to 1 2 3 4, and also we have given the matrix B equals to A 0 0 B, where A and B belongs to natural number n, right? So then we have given the four option. What is that? So first option we have given, there exists more than one but finite number of B such that AB equals to BA. And the second option we have given, there exists exactly one B such that AB equals to BA. And the third option we have given, there exist infinitely many B such that AB equals to BA. And the option D we have given, there cannot exist any B such that AB equals to BA, right? So we need to find that which option is correct. So the correct answer will be C, right? So let's see the solution. Let's see how the C will be correct option, right? So clearly see that here we have given the matrix A and B, right? So when we will calculate AB, so AB equals to 1 2 3 4 times A 0 0 B, right? So we'll multiply the first row of matrix A to the first column of matrix B, so we will find A. And then we'll multiply the first row of matrix A to the second column of matrix B, so we'll find 2B. And then we'll multiply the second row of matrix A to the first column of the matrix B, so we'll find 3A plus 4 times 0, that is equals to 3A. Then we'll multiply the second row of matrix A to the second column of the matrix B, so we will find 4B, right? And also when we will calculate BA, so BA will equals to A 0 0 B times 1 2 3 4, right? So it will equals to, we just need to multiply the first row of the matrix B to the first column of the matrix A, so we will find A. Then we need to multiply the first row of matrix B to the second column of matrix A, so we will find 2A, right? And then we need to multiply the second row of matrix B to the first column of the matrix A, so we will find 3B. And then we need to multiply the second row of matrix B to the second row of second column of the matrix A, so we will find 4B, right? So here we have calculated the value of AB and BA, right? So if AB equals to BA, so then we will get A equals to B, right? So we can say that now, hence AB equals to BA, so it's possible for infinitely many value of B, right? Because we can take any matrix B, like we can take 1 0 0 1, and also we can take the matrix B as 2 0 0 2, but there should be one condition, that A equals to B, right? So we can find infinitely many matrix B, right? So that's why option C is correct. So now we are going to discuss the next question. So in this question we have given a matrix A equals to 1 minus 2 3, then we have given minus 4 2 5, and we have given the matrix B equals to 2 3 4 5 2 1. Then we need to find that which option are correct, which option is correct. So the correct answer is B, right? So let's see that how the correct answer will be B. So let's start the solution. So here A is a 2 cross 3 matrix and B is a 3 cross 2 matrix, right? So both AB and BA exist, right? And AB is a 2 cross 2 matrix. Why? Because A is a 2 cross 3 matrix and B is a 3 cross 2 matrix, right? So when we will take the multiplication of this AB, so AB will be 2 cross 2 matrix, right? And since we have given that B is a 3 cross 2 matrix and A is a 2 cross 3 matrix, right? So that's why when we will take BA, so BA will be 3 cross 3 matrix, right? So we can say that AB is not equals to BA, right? Because we are getting AB as a 2 cross 2 matrix and BA as a 3 cross 3 matrix, right? So that's why AB is not equals to BA. So now we are going to solve the next question. So in this question, if omega not equals to A is the complex cube root of unity, and we have given the matrix H equals to omega 0 0 omega, then we need to find the value of S की power 70, right? So the correct answer is A, right? So let's discuss the solution, how the correct answer will be A, right? Clearly we have given H equals to omega 0 0 omega, so when we'll calculate H square, so the value of H square will be omega 0 0 omega times omega 0 0 omega, right? And when we'll multiply these two matrix, so we need to multiply the first row of the first matrix to the first column of the first matrix, the first column of the second matrix, so we will get omega square, right? And then we will get omega times 0 plus 0 times omega, so we will get the next element as a 0, right? And then we need to multiply the second row and the first column, so we will get omega times 0 plus 0 times omega, so we will get 0. And then we need to multiply the second row with the second column, so we will get 0 times 0 plus omega times omega, so we will get omega square, right? So we will get the value of h square equals to omega square 0 0 omega square, right? So similarly, when we will calculate the value of h cube, so means h square times h, means that omega square 0 0 omega square times omega 0 0 omega, right? So when we will multiply these two matrix, so we will get the value of h cube equals to omega cube 0 0 and omega cube, right? So see that here when we'll calculate the value of h square, so in the diagonal we are getting omega square. When we are calculating h cube, so in the diagonal we are getting omega cube and all the non-diagonal element are 0. So since similarly when we'll calculate the value of h ki power 70, so we will get the diagonal element h omega ki power 70 and all the non-diagonal element are 0. That means that h ki power 70 equals to omega ki power 70 0 0 omega ki power 70, right? So we can write this matrix as omega ki power 69 times omega 0 0 omega ki power 69 times omega, right? And we can write omega ki power 69 as omega cube ki power 23 times omega 0 0 omega cube ki power 23 times omega, right? So since we have given that omega is the complex cube of unity, omega is the complex cube root of unity, it means that omega cube equals to 1, right? So when we will put the value of omega cube, so we will find that the value of h ki power 70 equals to omega 0 0 omega. So thank you for your attention. I hope this session was useful.
Hello student, welcome to today's lecture. In today's lecture, we are going to learn about laws of motion, and this is theory part 2. This is our disclaimer. In today's lecture, we will cover first free body diagram, then we will understand constrained motion, after that equilibrium of concurrent forces, then we will learn friction, then types of friction, then angle of repose, and then angle of friction and angle of repose, then acceleration of a block on applying a force over a rough surface. So these are the topics of the today's lecture which we will cover one by one. All right, everyone. If yes, please write in the chat box or thumbs up. Yes. So first, free body diagram. So here question arises, what is free body diagram? So we can say a free body diagram is a visual tool used in physics and engineering to analyze forces acting on an object. Alright. So free body diagram consists of a simplified dramatic representation of a single body or a subsystem of bodies isolated entirely from its surroundings. Suppose here we have a body. Look at here. So there is a multiple forces in different directions. Alright, and we will learn each forces one by one. So while sketching a free body diagram, we have a following steps, or we can say we have a following forces should be kept in mind. So first we will talk about the gravity, or we can say weight. So here as shown in the figure, look at here, gravity is vertically downward. Always remember, always acts vertically downward. Alright, and second is here friction, denoted by F. So a force that opposes the relative motion acting tangentially along the contact surface in the opposite direction of motion. So if the motion of the block having in this direction, but the friction will acting opposite of the motion, it means right direction. Alright. And one is normal, a support force exerted by a surface acting perpendicular to the surface of contact. So here you can see N is equal to what? When we resolve the component of mg, there is a two forces, mg sin theta and mg cos theta. Yes or no? There is a two forces, and we can say N equal to mg cos theta. The important point here is this: normal force, or we can say normal reaction, always acts normal to the surface on which body is kept, as shown in the figure. So this is the perpendicular on the block. So here when we equate the forces, N equal to mg cos theta and mg sin theta equal to F. Alright. Now let's see when two bodies are connected by a string. So suppose we have a two bodies, or we can say we have a two objects, object A and object B. Alright. So when two objects are connected by a string, the tension is an internal force within the system. So here tension will act. But an external force when considering each point individually. So for a free body diagram of a object A, the strings exerts a pull towards B, and for a free body diagram of object A, or we can say for object B, the strings exerts an equal and opposite pull towards object A. So this is an applications of Newton's third law. You know Newton's third law? For every action there is an equal and opposite reaction force. So the string pulls on both objects simultaneously and equally in opposite directions. First one in this direction, second one opposite to in opposite to second tension. Look at here. So there is a two tension. First towards A, second towards B. All right. Now constraint motion. So here question arises, what is constraint motion? Think about it. So we can say constraint motion means motion that is restricted by some conditions or connections between between the particles or bodies involved. In simple words, when one body's motion depends on another body, their motions are said to be constrained. So look at here, we have a two blocks, block A and block B. All right. So the motion of block A and motion of block B are interdependent. So let's see. So when the two blocks A block and B block of masses m1 and m2 are in contact on a smooth frictionless surface and an external force F pushes them. Alright. So they move together as a single system. Single system means masses will add. So for this system, what will be the mass? So we can say total mass is equal to m1 plus m2, because the contact force between them prevents relative motion. Alright. So this is an application of Newton's second law of motion, which states the net force on an object is equal to its mass times its acceleration. You know Newton's second law of motion, F is equal to mass into acceleration. So to calculate the force, you need mass and the acceleration of given body. So just putting the value of mass and acceleration, you will be get the force. So acceleration of the blocks A is equal to force divided by total mass. So we know total mass is m1 plus m2. So acceleration will be force upon m1 plus m2, and the contact force acting normally between the two blocks, that is F, small f is equal to m2 into A, and we know the value of small a, that is the acceleration of the block. So just put the value of acceleration and you will be get the contact force between the two blocks, that is F into m2 divided by m1 plus m2. So A is the acceleration and small f is the contact force. Alright everyone. So look at here, a block system is shown in the figure. So we have a two masses m1 and m2, and a force F is applied on this. So in that case, the acceleration of the blocks A is equal to force divided by total mass. So we know the total mass small m1 plus m2. So just put the value and you will be get the acceleration of the blocks. Clear? Clear, Krishna? Now if we talk about the contact force, so to calculate the contact force between two blocks, the formula is small f is equal to m1 into acceleration. So just put the value of acceleration and you will be get the contact force between the two blocks. So it will be what? It will be m1 into F divided by total mass. So in our case, the total mass is m1 plus m2. So it will be what? m1 into F divided by m1 plus m2. Clear? All right. Now, here we have a block of mass small m rests on a fixed, perfectly smooth, frictionless inclined plane with an angle of theta. The block is physically constrained to move along the surface of this incline. So the force is acting on the block, the gravity that is acting always vertically downward. I think this is clear. Alright, vertically downward. And the normal force exerted by the plane acting perpendicularly, this one, to the surface. So to analyze this motion, the force of gravity is typically resolved into two components. One acting perpendicular to the incline, that is mg cos theta, and the other acting to the parallel, to the parallel, or we can say parallel to the incline, mg sin theta. So the normal force balances the perpendicular components of gravity, as there is a no motion in that direction. So n is equal to mg cos theta, or we can say mg sin theta is equal to F. I think the free body diagram of the block is clear. Yes, everyone? All right. So by applying Newton's second law, that is force is equal to mass into acceleration along the direction of motion, uh, one can determine the acceleration of the wall, acceleration of the block, and the resulting acceleration down the inclined plane is calculated as A equal to g sin theta, demonstrating how the constraint of the inclined surface dictates the final motion of the object. All right, everyone. Krishna, Varsha, and Sejanya, and Nikul. Everyone. Someone is IIT Bombay. Pratham. Yes. So the free body diagram of the block is clear. If yes, write in the chat box. All right. Let's see. Now, suppose we have a block. All right. So now we will calculate the acceleration. So if a block of mass m is placed on a smooth movable wedge of mass capital M, which is turn is placed on smooth surface, then a force capital F is applied on the wedge horizontally. Look at here. A force capital F is applied on the wedge horizontally. Both, listen carefully, both the wedge and the block will accelerate together in that case. Because there is no friction, the system behaves like a combined mass of capital M plus small m being pushed by the force F, as shown in the figure. Now, the acceleration A of the wedge and the block is given by Newton's second law. So we know the second law, force is equal to mass into acceleration. So using the Newton's second law, acceleration will be force upon total mass. So it will be F divided by m plus small m. This means the entire system moves with this acceleration due to applied force. So the force exerted on the block by the wedge can be expressed as F is equal to capital M plus small m into acceleration is equal to capital M plus small m into g tan theta, where g is the acceleration due to gravity and theta is the angle of wedge. This force arises because of block's weight component along the inclined surface of the wedge and the wedge acceleration. So now we have a 3 blocks. Listen everyone. Now we will uh, choose more than 2 blocks. They are interconnected, and we will find the acceleration, tension, force. All right. So this is very important for the exam point of view. So when blocks are interconnected with another blocks, and when blocks are interconnected with pulleys, then how we will calculate the acceleration, force. All right. So these are the steps uh, to calculate that formulas, that calculations. All right. So here we have a 3 blocks: block A, and block B, and block C. Look at here: A block, B block, or C block. So for a block of the block shown in the figure, where the 3 blocks with masses m1, m2, and m3 are connected and placed on a smooth surface. Smooth surface means frictionless surface. All right. So the acceleration of the entire system when a force capital F is applied, so it will be A is equal to, acceleration is equal to force divided by small m1 plus m2 plus m3. So when 3 blocks are interconnected and the force is applied on a block, so in that case the acceleration will be force upon total mass of that system. This is because the force is F accelerates the combined mass of 3 blocks equally on the frictionless surface, like a train. All right, like a train engine. And uh, we can say cabins are interconnected. Yes or no? Everyone. Varsha, Krishna, VK, Nikul. All right. So this is our 3 block system. Now for the block system shown in the figure, where 3 blocks with masses m1, m2, and m3 are connected and a force capital F is applied. So first we analyze the acceleration of the entire system. All right. So from this concept, listen everyone, from this concept, question asked in the exams. So what will be the acceleration? Think about it. If the blocks are interconnected, m1, m2, or m3. So the acceleration of the system A is equal to force, applied force divided by total mass. So just look at here. Total mass is what? m1 plus m2 plus m3. Yes or no? So using the Newton's second law of motion and Newton's second law, that is force is equal to mass into acceleration. So acceleration is what? Acceleration will be force upon total mass. So here total mass is m1 plus m2 plus m3. So the formula will be this one. Now if we talk about the tension between the blocks A, B, and B and C. So what will be the value of T1? What will be the value of T2? And the most important thing, how we can calculate T1 and T2. Alright. So listen everyone, because this concept is much important. Alright. So the tension in the string between the first and second blocks. So here first block A and the second block is B. So there is a tension T denoted as T1. So acts to pull the blocks M2 and M3 forward. Yes or no? So therefore it must provide the force necessary to accelerate both these masses together. So this gives the tension as T1 is equal to M2 plus M3 into acceleration. And we know the value of acceleration, that is F divided by m1 plus m2 plus m3. So just put the value of acceleration and you will get the tension in the string. Clear everyone? Now we will talk about the T2. So if we talk about the T2, so the tension in the string between the second block and third blocks denoted as T2. So acts only on the third block. Therefore, it is responsible for accelerating mass m3 alone. And so T2 equal to what? We can say T2 equal to m3 into acceleration. And I think you know the value of force. Yes or no? You know the value of acceleration. So just put the value of acceleration. So T2 will be force into m3 divided by m1 plus m2 plus m3. This one. Clear? So this is the tension T1 and tension T2 between the blocks. Now suppose for a block system in shown here. So now in the second case, the force, the direction of force will change. Alright. So in another configuration, the block system shown here, where the force is applied at the end of the block M3. So again, same question arises here. What will be the acceleration? What will be the tension T1 and T2? Yes or no? So firstly, uh, here this is homework to you to solve this type of arrangements. So let's see. So if we talk about the acceleration, so we know the Newton's second law, total force is equal to mass into acceleration. So acceleration A equal to force upon total mass, that is m1 plus m2 plus m3. Now tension in the string T1 equal to m1 here. In this case, the tension in the string between the blocks m1 and m2 denoted as T1. So must pull only block m1 forward. So it will be tension T1 equal to m1 into F divided by T1 m1 plus m2 plus m3 total mass. And if we talk about the T2, so tension in the string between blocks m2 and m3 denoted as T2. So pulls both blocks m1 and m2. Hence the tension T2 equal to m1 plus m2 into F divided by m1 plus m2 plus m3. All right. All right, Varsha, VK and Krishna. Now we have a suspended free rigid body. So consider a block system suspended freely from a rigid support as shown in the figure here. So the blocks with masses m1, m2 and m3 hang vertically one below the other, connected by strings. Since the system is at rest or moving with constant velocity, it means not accelerating. So the acceleration of the system is 0. So A equal to 0. So this means there is a no net acceleration acting on the blocks vertically, and the system is in equilibrium under the influence of gravity and the tensions in the strings. So let's analyze the tensions in the string holding the blocks. So the top string with tension T1 supports the entire weight of the all three blocks combined. Thus, the tension in the top string must balance the gravitational force on the total mass, which is the sum of m1, m2 and m3. Hence, T1 is equal to m1 plus m2 plus m3 multiplied by small g. We know small g is the acceleration due to gravity. And this tension ensures that the whole system is supported from the rigid body. Alright everyone. So the if we talk about the second string with tension T2. So the supports only the lower two blocks with masses m2 and m3. Therefore the tension T2 balances the combined weight of these two blocks. So the T2 is equal to m2 plus m3 into small c. And this force acts upward on block m2 to support the both m2 and m3 below it. So this is the formula to calculate the tension in the strings. Finally, the lowest string has tension T3, so which supports only the block with mass M3. So this tension balances the weight of the strings block hanging at the bottom. So T3 equal to M3 into small g. This is tension holds block M3 in equilibrium. Alright. Now we have a pulley. and M1, M2 and M3 are connected. So for the block system and the pulley shown in the figure, look at here, this one. We want to find the acceleration of the system when the three blocks with masses M1, M2 and M3 uh, are connected as shown. Alright. So the blocks M2 and M3 hang on one side of a pulley, and block M1 hangs on the other side. So the forces acting on the blocks include gravity and the tensions in the strings. So the net acceleration A of the system is given by A is equal to M1 plus M2. Listen carefully everyone. M1 plus M2 minus M3 into multiply by small g divided by M1 plus M2 plus M3. Alright. So this formula comes from applying Newton's second law to the entire system and considering the difference in gravitational forces on the two sides of the pulley. The term numerator M1 plus M2 minus here minus M3 into G represents the net driving force, while the denominator M1 plus M2 plus M3 represents the total inertial mass resisting acceleration. Clear Varsha? So if we want to calculate the tension T1 in the string segment supporting block M1, this tension depends on the interaction between M1 and M3. So the blocks on opposite side of the pulley, the formula for T1 is T1 equal to 2 into M1 into M3 into G divided by M1 plus M2 plus M3. And this tension arises because the force transmitted through the string must balance the gravitational force and the acceleration of these two masses. So the factor 2 here appears due to the pulley setup, which doubles the tension force in the segment. Alright. So if we talk about the T2, so the formula will be what? So we can say the tension T2 in the string segment supporting the blocks M2 and M3 in next, yes or no? So this tension balances the combined effect of the masses M1 and M2 on the other side. So the formula T2 equal to 2 into M3 into M1 plus M2 into small g divided by M1 plus M2 plus M3. This tension accounts for the fact that blocks M2 and M3 are connected on one side of the pulley, requiring the string tension to support their combined influence. So finally the total tension T in the main string passing over the pulley is twice the tension T2. Alright. So since the pulley has two segments of the string supporting the load, therefore T equal to 2 into T2. So just put the value of T2, you will be get 4 into M3 into M1 plus M2 into small g divided by M1 plus M2 plus M3. This total tension T reflects the force exerted by the pulley on its supports, which must counteract the combined weight and dynamic effects of the block in motion. So all the formulas T1, T2 and total tension are important for the exam. Now here for the pulley and blocks arrangement as shown in the figure, here we have a masses M1, M2 and capital M. So consider the pulley and block arrangement shown in the figure where the two blocks with masses M1 and M2 are connected by strings, alright, passing over pulleys, and a pulley frame with mass capital M is involved. So the system is constrained such that the motion of the block is interconnected and the pulley frame mass influence the dynamics. So our goal is to find the acceleration of the blocks and the tensions in the strings. So net acceleration is equal to net accelerating force divided by total mass. So here net accelerating force is M1 minus M2 into G and divided by M1 plus M2 plus capital M. This formula tells us how the acceleration depends on the imbalance of the two masses relative to the total being accelerated. So next tension T1. So consider the tension T1 in the string connected the block M1 which moves downward with acceleration A. So by Newton's second law, the tension must balance the weight of m1 minus force causing acceleration. So this gives T1 is equal to m1 into g minus a. So substituting the value of a, and you will be get the value of T1. So that is m plus 2 into m2 into m1 into g divided by m plus m1 plus m2. This expression shows that T1 depends not only on m1 and its acceleration but also on the pulley's frame mass, capital M, and the other block m2, reflecting the constant nature of the system. So similarly, we can calculate T2. So it will be T2 equal to m2 into g plus a, which is just put the value of here a, and simplifying you will be get T2 equal to m plus 2m1 into m2g divided by m plus m1 plus m2. This tension depends only depends on m2, its acceleration, the pulley's frame mass, and the other block m1. Again, showing the interdependence of the system's components. So here, these formulas, all formulas are important. All right. So you need to remember this. Now here, for the system of block and pulley with a smooth inclined plane as shown in the figure. So as you already learned to draw how to draw the free body how to draw free body diagram. So here weight is mg and any normal reaction. So components of mg is m2g, components m2g is m2g sin theta and m2g cos theta. All right. So in that case, the next acceleration here will be m1 minus m2 into sin theta into g divided by m1 plus m2. There is a condition if m1g into m1g is greater than m2g sin theta. And if we talk about the acceleration, so it will be m2 sin theta minus m1 into g divided by m1 plus m2. And the condition is if m1g is less than m2g sin theta. So tension in the string T equal to m1 into g minus a, which is equal to m1 m2 into 1 plus sin theta divided by m1 plus m2. So for the pulley and the block system on a smooth double inclined plane as shown in the figure, we have uh, two masses m1 and m2. So the first incline has angle theta 1 and the second has angle theta 2. Alright. So each mass experiences a component of its weight pulling its down its respective incline. So m1g sin theta 1 and m2g sin theta 2. If one incline is steeper or one mass heavier, the system will accelerate accordingly. For example, if theta 2 is greater than theta 1 and m2 is greater than m1, then m2 pulls the system such that it moves down its incline while m1 moves up its incline. So the net force causing acceleration is difference between two components of the weight pulling the masses down their incline. Alright. So F net is equal to here m2g sin theta 2 minus m1g sin theta 1. Because of masses are connected, they accelerate together with magnitude a. So the total mass being accelerated is m1 plus m2. So Newton's second law gives A is equal to F net divided by m1 plus m2. Just put the value of F net, you will be get m2 sin theta 2 minus m1 sin theta 1 into g divided by m1 plus m2. And tension in the string T is equal to m1 into m2 sin theta 1 plus sin theta 2 into g divided by m1 plus m2. Now let's see equilibrium of concurrent forces. Alright. So when several forces act simultaneously at a single point on a body, these forces are known as concurrent forces. The key characteristics of concurrent forces is that their lines of action all intersect at one point. So the situation often arises in practical problems involving cables, ropes, or forces acting on a joint or hinge. So the necessary conditions for the equilibrium of a body under the actions of concurrent forces is that the vector sum of all the forces acting the body must be 0. So F net equal to 0. So mathematically, the equilibrium f net equal to 0. So summation fx is equal to 0, summation fy equal to 0, and summation fz equal to 0. Alright. Now we will see Lami's theorem. So we can say Lami's theorem is a special and elegant result for the equilibrium of the three concurrent forces. It states that if three forces P, Q, and R acts on a point, thus keep the body in equilibrium, then each forces is proportional to the sine of the angle between to the other forces. So the diagram shows three forces F, P, Q, and R acting on a point with angles alpha, beta, and gamma between them. Clear everyone? As shown in the figure. So the angles in the figure corresponds to the angles opposite the forces. So the forces and the angles are arranged such that the vector sum of the three forces is 0. So meaning the forces from a closed triangle when placed head to tail. So Lami's theorem thus provide a direct way to calculate the magnitude of one force if other two forces and angles between them are known. So it will be P divided by sine alpha is equal to Q divided by sine beta equal to R divided by sine gamma. And this is very important. Now let's see friction. So whenever an object actually slides, or we can say actually rolls over surface of another body or tends to do so, a force opposing the relative motion starts acting between these two surfaces in a contact. So it is known as friction or frictional force due to friction. So force of friction acts in a tangential direction of the surfaces in contact. Alright. So when you walking, uh, the force applied in forward, but the frictional force applying backward. So there are four types of frictional force. First, static friction. Alright. So it is the opposing force that comes into play when the body is at rest, and the force acts to move it over the surface of the another body. Second, this friction, static friction, is a self-adjusting force. Is always equal and opposite to the applied force. Second is limiting friction. So in that case, value of static friction is maximum when body is just on the verge of starting its motion over the surface of another body. So the force of limiting friction FL between the surface of two bodies is directly proportional to the normal reaction at the point of contact. So mathematically FL is directly proportional to N. So FL equal to mu N. Alright. So mu L is equal to FL divided by N. And mu L is the coefficient of limiting friction. From this concept, question asked in every year. So third is kinetic friction. It is the opposing force that comes into play when one body actually slides over the surface of another body. So force of kinetic friction Fk is directly proportional to the normal reaction, and the ratio Fk by N is called coefficient of kinetic friction mu k. Value of mu k is slightly less than mu L, so we can say mu k is less than mu L. Next one is rolling friction. It is the opposing force that come into play when a body of symmetric shape rolls over the surface of another body. So force of rolling friction Fr is directly proportional to the normal reaction and inversely proportional to the radius of the wheel. So it will be Fr equal to N by Fr is directly proportional to N by R, or Fr is equal to mu R into N divided by R. Alright. So these formulas are booster for your work as a booster for your exam. So the constant mu r is known as coefficient of rolling friction. Mu r has the unit and the dimensions of length. So magnitude wise, mu r is less than mu k or mu l. The value of rolling friction is much smaller than the value of sliding friction. Alright. Ball bearings are used to reduce the wear and tear and energy loss against friction. Next is angle of friction. So angle of friction is defined as the angle theta which the resultant r as shown in the figure. Resultant are of the force limiting friction FL and the normal reaction N. Alright. So substance angle normal reaction is theta here and applied force in this direction. So the tangent to the angle of friction is equal to the coefficient of friction, that is mu equal to tan theta. Angle of repose. Angle of repose is the least angle of the inclined plane with the horizontal, such that given body placed over the plane just begins the slide down without getting accelerated. So the tangent of the angle of repose is equal to the coefficient of friction. Hence we conclude that angle of friction theta is equal to the angle of repose phi. So in limiting friction, FL is equal to mg sin phi. These relations are important. And equal to mg cos phi. Alright. And so FL divided by n is equal to tan phi. FL divided by n equal to mu s equal to tan phi. Now acceleration produced by applying force to a block placed on a rough surface. So acceleration of a block on a horizontal surface is this one, like look like this. Weight is mg, normal reaction s, this is applied force and this is frictional force. Alright. So acceleration of block A is equal to F minus F divided by M. So just put the value of F, it will be mu mg. So F minus mu mg divided by M. Okay, or A is equal to F by M minus mu g, where mu is the coefficient of friction between two surfaces in contact. Acceleration of block sliding down on a rough inclined plane is shown in the figure given by this one. So we are already learned when a body is placed on an inclined plane, so there is a more than one forces will act. So the weight mg, the components of mg sin alpha and mg cos alpha. Alright, and normal reaction. So it in that case A equal to g into sin alpha minus mu cos alpha. Alright. So we can say here retardation of the block sliding up a rough inclined plane as shown in the figure is A equal to g into sin alpha plus mu cos alpha. Alright, everyone. Thank you. Now we will learn circular motion. Are you ready for the circular motion, everyone? If yes, write in the chat box or we get thumbs up. Everyone. Hello, everyone. Now we will learn about circular motion, and this is a very important concept for the exam. Alright. So here you need to remember all the formulas which we will discuss in upcoming slides. So this is our index and this is our disclaimer and this is our index. So in today's lecture we will discuss first concept of circular motion, then terms related to the circular motion, then dynamics of uniform circular motion, then forces in circular motion, then motion of a vehicle on a level a circular road, then being of a catalyst cyclist, okay, being bending of a cyclist, then banking of a curb road, uh, motion of a cyclist in a depth well, then motion along a vertical circle. All right. So these are the topics of the today's lecture which we will learn one by one. So concept of circular motion. So we can say circular motion is a two-dimensional motion. It refers to the movement of body along the circumference of a circle or a circular path. All right. This motion inherently occurs in two dimensions because the object moves in a plane, changing both its position in the x and y direction simultaneously. So, circular motion can be classified into two types: uniform circular motion and non-uniform circular motion. If we talk about the uniform circular motion, so we can say the object moves at a constant speed. And if we talk about the non-uniform circular motion, the object speed varies during motion. This classification helps understand the nature of the forces and the acceleration acting during circular motion. Alright, so we can say uh, if the radius of the circle is r, alright, and the constant speed is v, then the magnitude of the centripetal acceleration is AC is equal to v square by r. Yes or no? So in non-uniform circular motion, the object travels around the circle at a constant speed. Although the speed is constant, the velocity is not constant because velocity is a vector quantity that includes direction. Since the direction of velocity changes continuously as the object moves along the circular path, the object experiences an acceleration called centripetal acceleration directly towards the center of the circle. And in non-uniform circular motion, the speed of the object changes as it moves along the circular path. This means the object has both centripetal acceleration, changing direction of the velocity, and tangential acceleration, changing magnitude of velocity. Alright. So the centripetal acceleration still acts radially inward, changing the direction of velocity, and the tangential acceleration acts along the tangent to the path. Alright, changing the speed. Thus, that acceleration is a vector sum of centripetal acceleration and tangential acceleration. So, this results a more complex motion dynamics compared to the uniform motion. So, here you need to differentiate the uniform circular motion and non-uniform circular motion. Touch it. Terms related to circular motion. So, first we have an angular displacement. If we talk about the angular displacement, we can say angular displacement is the angle through which an object rotates about a fixed axis. It is denoted by delta theta and measured in radians. Alright, if we talk about the examples, we can say when you open a door, the door rotates about hinge, yes or no? So the angle from the closed to the open position is angular displacement. Second is angular velocity. So if we talk about the angular velocity, so we can say angular velocity omega is the rate of change of angular displacement with respect to time. It tells how fast something is rotating. All right. So from here, from the figure, look at here. Here a figure, blocks are in this figure. You can see uh, a circular track having radius small r. The angular displacement is delta theta and the velocities vectors v1 and v2. Alright. So at 2 points on the path, these velocity vectors are tangential to the circle, indicating directions of linear velocity. But the angular velocity vector points along x-axis along the axis, all right, perpendicular to the plane of the circle. So if we talk about the formula, so angular velocity omega is equal to limit delta t approaches 0 delta theta upon delta t. Here delta t approaches 0 means delta t is not, delta t approaches 0, delta t is not equal to 0, all right, delta t approaches 0. So omega equal to d theta upon dt. Now angular acceleration. So if we talk about the angular acceleration is a fundamental concept in circular motion, all right, that describes how quickly the angular velocity of particle changes with time. And we talk about the mathematically, so we can say angular acceleration is defined as the rate of change of angular velocity with respect to time, all right. If omega represents the angular velocity, then the angular acceleration alpha is equal to d omega upon dt. So omega, since angular velocity omega itself is the rate of change of angular displacement theta with respect to time, so we know omega is equal to d theta upon dt. So angular acceleration can also be expressed as a second derivative of angular displacement with respect to time. So alpha equal to d square theta upon dt square. This means angular acceleration measures how the angular position's rate of change is accelerating or decelerating over time. If we talk about the unit, so we can say the units of angular acceleration is the radians per second squared, written as radian per second square, all right. So all the formulas are very important. Clear? uh, Varsha, VK, Krishna, everyone, clear, yes or no? Varsha, any doubt? If you anyone, any doubt? I think all the formulas and the concepts are clear with their unit. VK, yes or no? All right, good. So unit is radian per second square. Dynamics of uniform circular motion. So suppose a particle moves along a circular path. Here we have a circular path. This one, particle moves with a uniform speed, meaning that its speed remains constant as it travels around the circle. This motion is called uniform circular motion. In such a case, the speed v, here the speed v is 0. So if the speed is 0, so we can say dv upon dt equal to 0, and acceleration is equal to, angular acceleration is equal to omega square r, which is equal to v square by r. So even though the speed is constant, the velocity is not constant, because velocity is a vector quantity. So that depends on both magnitude and direction. Alright, since the direction is continuously changing as the particle moves on the circle, so the particle experiences an acceleration. This acceleration is directed towards the center of the circle and called centripetal acceleration. Directed towards the center, alright, towards the center O. So the magnitude of the centripetal acceleration AC is related to the angular velocity omega, and the radius r of the circle by given by the formula AC equal to omega square by r. So we know linear speed v and angular velocity omega are related. So v is equal to r omega. So we can write centripetal acceleration, that is v square by r. This v square by r. All right, v square by r. This one. So here in a non-uniform circular motion, resultant acceleration of the body is a equal to under root ar square plus at square, which is equal to under root v raised to the power 4 divided by r square plus r square into alpha square, where at is equal to what? At is equal to dv upon dt. Forces in circular motion. So in circular motion of an object, two kinds of forces occur, which are described below. First, centripetal force. So the centripetal force is the force necessary to keep a body moving along a circular path with a constant speed. This force acts along the radius pointing towards the center of the circular path. Alright. So without this inward force, the objects would move off in a straight line due to inertia. Thus, the centripetal force continually changes the direction of the object's velocity, keeping it in circular motion. So the magnitude of the centripetal force F can be expressed as F equal to mv square by r. So it is equal to mr omega square. So it is equal to mr 4 pi square divided by t square. We know v is equal to r omega. So the relation connects linear speed and angular velocity. So term 4 pi square divided by t square comes from expressing angular velocity in terms of the period t. The most important thing, work done. So the work done by the centripetal force is always zero. This is because the centripetal force acts perpendicular to the velocity vector, which is tangent to the circle, and the work done is the force component in the direction of displacement. Alright. So since the displacement is at instant is along the velocity, the centripetal force is perpendicular to it. No work is done by this force. Second force is centrifugal force. So centrifugal force is a perceived force that acts radially outward on a body, radially outward on a body, moving in a circular path, as observed from a rotating frame of reference moving with the body. Alright, so it is the reaction force that seems to push the body away from the center, but it is not a real force acting on the body in an inertial frame, because it arises due to the non-inertial rotating frame of reference of the observer moving with the body. The centrifugal force is classified as a pseudo force. It does not exist in an inertial frame, but it is useful for analyzing motion from the rotating frame. Mathematically, the magnitude of the centrifugal force is the same as that of centripetal force, but directed outward. So F centrifugal is equal to mv square by r. So it will be equal to mr omega square. Again, v is equal to r omega. This equality shows centrifugal and centripetal forces have equal magnitudes but opposite directions. Depends on the frame of references. Alright. So now let's see motion of a vehicle on a level circular road. When a vehicle moves along a circular path, it must experience a centripetal force to keep it moving in that curved trajectory rather than in a straight line. Alright. So this force acts inward towards the center of the circle. Without this force, the vehicle would continue moving tangentially due to inertia and thus leave the circular path. So here the weight is mg, normal reaction n, and F is the force. In practical situations, the lateral force of friction between the vehicle's tires and the road surface often provides this necessary centripetal force. This frictional force acts sideways to prevent the tires from slipping outward, thus enabling the vehicle to follow the circular path. For the vehicle to maintain its circular motion without slipping, the required centripetal force must be less than or equal to the maximum available frictional force. So mathematically, this can be expressed mv square divided by r is less than equal to frictional force. From the inequality above, we can solve the maximum speed. Vmax, the vehicle can safely have without slipping outward. So Vmax is equal to under root mu rg, and this is very important concept for the exam. All right. So you need to write this formula and remember this formula. This is the safe velocity, safe maximum velocity. This formula tells us that the maximum speed depends on the coefficient of friction mu and the radius r of the curve and the acceleration due to gravity small g. The coefficient of friction mu depends on the condition of the road and the type of tires. So r is the radius of the curve and curve of the vehicle is negotiating. If the vehicle exceeds the maximum speed, the frictional force will no longer to be sufficient to provide the centripetal force and the vehicle will skid or slip outward. Bending of a cyclist. So, when a cyclist goes around turns on a circular track, alright, the cyclist must lean at a certain angle with respect to vertical to maintain balance and avoid falling outward due to inertia. Alright, so this lean angle theta depends on the speed of the cyclist, the radius of the turn, and gravity. So the lean is necessary because the cyclist and bicycle experience a centripetal force directed toward the center of the circular path. This force is provided by the horizontal component of the normal force exerted by the ground on the cyclist. Alright. So to analyze the forces, consider the force acting on the cyclist, the weight mg vertically downward. Alright, the normal reaction r. Alright, from the ground acts perpendicular to the vehicle's frame, making angle theta. With the vertical, the components of the normal force are n cos theta, balancing the vertical weight mg sin theta, mg and n sin theta. All right. So providing the centripetal force to turn the cyclist n sin theta. So from the force balance in vertical direction n cos theta equal to mg, and its horizontal direction centripetal force n sin theta equal to mv square by r. Alright. So tan theta equal to v square by rg is equal to tan inverse v square by rg. Banking of a curb road. For the safe journey of a vehicle on a curved circular road without any risk of skidding, the road is slightly raised toward its outer end. This banking helps the vehicle negotiate the curve safely by providing inward force component that assists the frictional force in preventing the vehicle from slipping outward. So let the road be banked at an angle theta as shown in the figure. This angle is the inclination of the road surface relative to the flat horizontal ground. When the vehicle moves on this banked curve, the force is acting on it changes because of the slope. So tan theta equal to v square by rg. Alright? Yes or no? So when friction is present, right, between the road and vehicle's tire, in that case, uh, it affects the maximum speed and the vehicles can safely take the curve without skidding. The frictional force can either add to or oppose the component of forces keeping the vehicle on its path. So the maximum speed Bmax is equal to under root Rg mu s plus tan theta divided by 1 minus mu s tan theta. So where mu s is equal to coefficient of static friction. All right. So this formula. You need to learn all these formula for boost your preparation. All right. You are already learned all the terms. Motion of a cyclist in a death well. So the death well is a vertical cylindrical wall inside which a cyclist can ride horizontally without falling down like this. So for the cyclist to remain in equilibrium while moving inside the well, certain forces must balance. All right. The normal reaction force N from the wall provides the necessary centripetal force that keeps the cyclist moving in a circular path around the vertical wall. At the same time, the force of friction between the cyclist tires and the walls must balance the cyclist weight mg, where m is the mass of the cyclist and vehicle, and g is the acceleration due to gravity. This frictional force prevents the cyclist from sliding down due to gravity. So mathematically, the normal reaction N acts horizontally, providing the centripetal force required for circular motion at speed v and radius r of the well. So N equal to mv square by r. This formula states that the normal force is proportional to the mass square of the velocity and inversely proportional to the radius of the circular path. So the frictional force small f acts vertically upward opposing the cyclist. The frictional force is related to the normal force by coefficient of friction mu. So F is equal to mu n. Since the friction balances the weight, we set mu n equal to mg. So substituting the expressions for N from the centripetal force, the equation into the friction gives mu mv square by r equal to mg. Simplifying the mass, cancel out mu into v square by r equal to g. So solving the maximum speed Vmax the cyclist can have without slipping down is Vmax is equal to under root Rg divided by mu. This formula shows that the maximum speed depends on the radius of the circular wall, gravitational acceleration, and the coefficient of friction between the tires of the wall. Alright. So now we will see motion along a vertical circle. So in a uniform circular motion, speed of object decreases due to effect of gravity as goes from lowest point A to highest point B. This decrease in the speed due to effect of gravity acting on the object. Alright, so gravity pulls the object downward. So as the object climbs up from A to B, it loses kinetic energy and slows down. Conversely, if the object moves downward B to A, it speeds down. So the variation in speed makes the circular motion non-uniform. So at the lowest point A of the vertical circle, look at figure, the force is acting on the object, tension TL in the string or rod holding the object. So the weight mg of the object acting vertically downwards, look at here, alright, and TL and mg acts in opposite direction. So the tension acts upwards while the weight acts downward. So the net force towards the center of the circle at point A provides the centripetal force. So according to Newton's second law, we can write TL minus mg equal to mv square L divided by R. So rearranging the terms, we will get TL equal to mg plus mv square L divided by R. This means the tension at the lowest point is the sum of the weight and the centripetal force. So at the highest point B, tension TH and the weight mg are in the same direction and hence TH plus mg is equal to mv square h divided by r, or TH is equal to mv square h divided by r minus mg. So the tension at the top is the centripetal force minus weight of the object. Moreover, VL and VH are the correlated as V square h is equal to V square L minus 2GH. Motion along a vertical circle. So if a particle revolves in a vertical circle of radius r and at some instant it is at position C as shown in the figure, so which is inclined at angle theta from the vertical, so the velocity squared at position C is given by v square equal to v square L minus 2gr into 1 minus cos theta, where VL is the velocity of the lowest point, G is the acceleration due to gravity, and R is the radius of the circle. This comes from the conservation of mechanical energy as the particles moves from the lowest point to position C, it gains height. So R into 1 minus cos theta loses the kinetic energy accordingly. And the tension T in the string, this position C, is T equal to mg cos theta plus mv square by R. So the critical condition occurs when the particle just completes the loop without the string going slack. That is, the tension at the highest point V becomes 0. So Th equal to 0. Under this condition, following results hold: Th equal to 0, TL equal to 6 mg, VL equal to under root 5 Rg, and VH is equal to under root Rg, where TL is the tension at the lowest point, VL and VH are the velocities at the lowest point and highest point respectively. In general, the difference between tensions at the lowest and the highest point is TL minus Th is equal to 6 mg. This relation holds for critical looping condition. Alright, so when a vehicle is moving over a convex bridge, the maximum velocity V equal to under root Rg, where R is the radius of the rod. And this formula is very important for the exam. Now, motion along a vertical circle. When a, when a vehicle moves over a convex curve like a top of a hill or bridge, look at here, this one. So it reaches a maximum height point, say point A. Alright. At this point, the vehicle experiences a downward gravitational force mg, where small m is the mass of the vehicle and g is the acceleration due to gravity. Alright. So the vehicle also has a velocity v along the curved path with radius r. So to keep the vehicle moving along the curved path, a centripetal force mv square by r directed towards the center of the curvature is required. So at the maximum height, the rod exerts a normal force upward. Alright. So the normal force upward opposing the weight of the weight and the providing part of the centripetal force. The balance forces along the vertical direction gives n1 plus mv square by r equal to mg. So rearranging the term, you will get n1 is equal to mg minus mv square by r. This means the normal reaction force decreases as the velocity increases. If the velocity reaches a critical value such that uh, when the uh, when the vehicle is moving in a dip B, so then N2 equal to mg plus mv square by r. Here normal force is greater than the vehicle's weight because it has to provide the centripetal force in addition to supporting the weight. This means the vehicle feels heavier at dip and lighter at the crest of the rod. Alright. Thank you for your attention. Now we will solve some practice questions based on these topics. Are you ready for the questions? Yes or no? Everyone, please answer in the chat box. Hello students. Now we will solve some practice questions based on laws of motion. Alright. So are you ready for questions? This is disclaimer. So here we will learn some practice questions based on laws of motion. Alright. So our first question. So firstly, here you need to try this question. two bodies of equal masses are connected by a light inextensible string passing over a smooth frictionless pulley. Smooth frictionless pulley means the frictional force is zero. The amount of mass that should be transferred from one to another so that both the masses move 50 meter in 5 seconds is what. So here you have to find out the uh, how much mass is transferred. Given options: 30%, option B is 40%, option C 70%, and option D 50%. So which one is correct? Please try to solve this question, everyone. Varsha, VK, Krishna. Yes. Which option is correct? Yes, please try to solve this one. So correct option is B. All right. So here, according to question, amount of mass that should be transferred from one to another. So suppose the mass is transferred from this block to this block is delta m. So in that block, the total mass will be what? So we can say m minus delta m is equal to m2 for the second block, and m plus delta m is equal to m1 for the first block. All right, and body moves vertically upward. So we know equation of motion S is equal to ut plus half at square. So to solve this question, we will use this concept. So just put the values according to question. Mass is moved 50 meter. So S is equal to 50 is equal to initial speed 0 u 0 into 5 plus 1 by 2 a t square. T is the 5 second. So solving this, you will be get a, that is 100 by 25. So 100 by 25 is 4 meter per second square. Alright, so let the mass of one become m1 and that other m2 where m1 is greater than m2. So as m1 moves downwards with acceleration a equal to 4 meter per second. So acceleration is equal to m1 minus m2 divided by m1 plus m2 into small g. So just put the value m1 minus m2 divided by m1 plus m2 equal to a by g. So solving this, you will be get percentage of mass transferred. So m1 minus m2 divided by m1 plus m2 into 100. So it will be 2 by 5 into 100%. 100 it is equal to 40%. Okay. Yes, clear everyone? Yes or no? So a man slides down a light rope whose braking strength is eta times his weight. What should be his maximum acceleration so the rope does not break? So here you have to find out the maximum acceleration. Given option A g into 1 minus eta, option B n eta g, option C g divided by 1 plus eta, and option D g divided by 1 minus eta. So which option is correct? Think about it and please try to solve this one, everyone. Which one is correct? Yes. correct option is A. So here man slides down a light rope whose breaking strength is eta. All right. So the weight of the man is vertically downward mg. All right, and there is a tension in the string that is less than equal to eta mg. All right. So when we equate both terms, or we can say T here as a R normal reaction. So as mg minus R equal to ma. All right. So just put the values. We know mg minus the value of R here eta mg equal to ma. So it will be mg into 1 minus eta equal to ma. So here the same terms are cancelled out. The remaining term A is equal to eta into 1 minus g into 1 minus eta. All right. Yes or no? Two blocks of masses m and capital M are connected by uh, means of a metal wire of cross sectional area A passing over a frictionless fixed pulley as shown in the figure. So the system is then released if m is equal to 2m. Then the stress produced in the wire is what? So here you have to find out the stress. Given options: option A 2mg divided by 3a, option B 4gm divided by 3a, option C gm divided by a, and option D 3mg divided by 4a. Which option is correct? Think about it and please try to solve this question. Yes, which one is correct? So correct option is B. Let's see the solution. So as we know, uh, tension in this string T equal to 2 into m1 into m2 divided by m1 plus m2 into g. So just put the value of masses. You will be get 2m into 2m divided by m plus 2m into g. You will be get 4 by 3 into mg. So we know stress is equal to force upon area. So just put the value of force and A. You will be get 4 mg divided by 3a. All right, everyone. So that's all for the today. Thank you for your attention. All right. Thank you. Any doubt? If you have any doubt, please ask. Yes. All right. Thank you.